はいどうも、バーチャルテックポエマーのコーチです。この配信はですね、GTC2026 が、開催されましたので、なんとなくね、せっかく見るんだったら配信しながら見ようかなというだけになっています。さすがにね、今日本だから朝3時ですから、さすがに見てる人はいないんじゃないかなと思いますけどね、あんまり。私は頑張って今日はね、夜勤のように早起きをしましたよ。収益化しなくていいや。収益化は無視すれば別に再生できるから。はい。そろそろ来るか？来たか？そろそろ始まるか？これはあれか、私 YouTube の方見ないと画像が逆さまなのでは説があるね。来たぞ。
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge and drawing on all we have learned. Tokens are harnessing a new wave of clean energy.
トークンが重要だって言ってますね。ニューエナジー。
And unlocking the secrets of the stars.
トークンめっちゃエネルギー使うからね。そこら辺の話っていうのかな。
To help robots learn. And in the physical world, perfect.
うまくつけれればいいんだけどね、ニコニコっていうかこのバーチャルテスト。
New paths. And clearing the way for a bountiful harvest.
これかっこいいよね。農場さ、最新の草取り機っていうか、農場の草取り機ってもう農薬とかじゃなくてさ、レーザーでねパチパチ焼いていくんだよ。日本ではサイズ的にあまり入らないんじゃないかという気もするけど、
They work where human hands cannot. So we may all breathe easier. And the smallest hearts beat stronger. Break new ground on a scale never attempted to empower the world. So we can reach
Star Cloud 1 separation confirmed.
Well beyond it. Take the next great leap into a bright new future.
の方だったら実は字幕がつくかと思ったけど、つかなかったから、気合で頑張ってたね。
For all mankind.
TOEIC の力を今こそ発揮すべし。
And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
来るぞ、革ジャン来るぞ。革ジャン、マジいつも革ジャンだよね。おー、イエーイ。パチパチパチパチパチパチ。カモン、革ジャン。
Welcome to GTC!
GTC! Hey!
I just want to remind you, this is a tech conference. All these people lining up so early in the morning, all of you in here, it's great to see you. GTC. GTC, we're going to talk about technology. We're going to talk about platforms. NVIDIA has 3 platforms. You think that we mostly talk about one of them. It's related to CUDAx. Our systems is another platform. And now we have a new platform called AI Factories. We're going to talk about all of them. And most importantly, we're going to talk about ecosystems. But before I start, let me thank our pre-game show hosts. I thought they did a great job. Sarah Go of Conviction, Alfred Lim, Sequoia Capital, NVIDIA's first venture capitalist, Gavin Baker, NVIDIA's first major institutional investor. These 3 people are deep in technology, deep in what's going on, and of course, they have just a really broad reach of technology ecosystem. And then, of course, all of the VIPs that I hand-selected to join us today, all-star team. I want to thank all of you for that. I also want to thank all the companies that are here. NVIDIA, as you know, is a platform company. We have technology, we have our platforms, we have rich ecosystem. And today, there are probably 100% of the $100 trillion of industry here. 450 companies sponsored this event. I want to thank you. 1,000 technical sessions, 2,000 speakers. This conference is going to cover every single layer of the 5-layer cake of artificial intelligence, from land, power, and shell, the infrastructure, to chips, to the platforms, the models, and of course, the most important, and ultimately, what's going to get this industry taken off is all of the applications. What it all began here. This is the 20th anniversary of CUDA. We've been working on CUDA for 20 years.
20ってなんか次世代っていうのはやっぱクーダ
For
タイルの話する
20 years,
のか
we've
な
been dedicated to this architecture, this revolutionary invention, SIMT,
次世代
single
まあ
instruction,
ルビンベラル
multi-threaded,
ビンの話はすると思うん
writing
ですよね
scalar code could spawn off into multi-threaded application, much, much easier to program than SIMD. We recently added tiles so that we could
やっぱタイルの話して
help
るね
people program tensor cores and the structures of mathematics that are so foundational to artificial intelligence today.
クーダタイル使うとねだい
Thousands
ぶなん
of
か
tools
テン
and
ソロバーを活かしやす
compilers
くなる
and
らしいんだよね
frameworks and libraries. In open source, there's a couple of 100,000 public projects. CUDA literally is integrated into every single ecosystem. This chart basically describes 100% of NVIDIA's strategies. You've been watching me talk about this slide from the very beginning. And ultimately, the single hardest thing to achieve is the thing on the bottom, installed base. It has taken us 20 years to now have built up hundreds of millions of GPUs and computing systems around the world that run CUDA. We are in every cloud.
まあ
We're
20
in
年
every
間ク
computer
ーダを
company.
ずっとやってた
We
っていう
serve
前
just
置きが
about
ある
every
か
single
ら
industry. The
やっ
installed
ぱクーダ
base
タイプとかグロ
of
ックの
CUDA
話しそうだよ
is the reason why the flywheel is accelerating. The install base is what attracts developers, who then creates new algorithms that achieves a breakthrough. For example, deep learning. There are so many others. Those breakthroughs leads to entirely new markets, which builds new ecosystems
ディープ
around
ラー
them
ニングは確
with
かに
other
ね
companies that
あ
join,
の
which creates a larger install base.
なんだろうな
This
クーダというか GPU に
flywheel,
とっても
this
天気だった
flywheel
し
is
ディ
now
ープラーニングに
accelerating.
とっても
The
GPU
number
天
of
気だった
downloads
よ
of
ね
NVIDIA libraries is incredibly accelerating. It's at a very large scale and growing faster than ever.
ね字
This
幕欲しいよ
flywheel is what makes this computing platform able to
気合い
sustain
ですね
so much
今ね
applications,
YouTube 公式
so
見てんだ
many
けど
new
ね YouTube
breakthroughs,
公式
but most
も
importantly,
YouTube 側からもちょっと字幕がなんかうまくつけれないん
it
だよね
also
なんでかわかんないけ
enables
どまあ
these infrastructures to have extraordinarily useful life. And the reason for that is very obvious.
今度、
There's
字幕
so many
VCI はやっぱ欲
applications
し
that
い
you
か
can
な。
run on NVIDIA CUDA. We support the entire, every single phase of the
字
AI
幕
life
VCI って
cycle.
誰か作ってないか
We
な。
address every single data processing platform. We accelerate scientific principled solvers of all different kinds. And so the application reach is so great that once you install NVIDIA GPUs, the useful life of it is incredibly high. It is also one of the reasons why Ampere, that we shipped them some 6 years ago, the pricing of Ampere in the cloud is going up. And so all of that is made possible fundamentally because the install base is high, the flywheel is high, the developer reach is great.
い
And
つ
when
もの
all
服だ
of
から
that
ね。
happens, and we
でもこの革
continuously
ジャンめっちゃ
update our
高いらしいよ。
software, the computing cost declines.
普通
The
にね、
combination of
数万
accelerated
円とかの世界
computing
じゃないらしいよ。
speeding up applications tremendously. Meanwhile, as we continue to nurture and continue to update software over its life, not only do you get the first time pop, you get the continuous cost reduction of accelerated computing over time. And we're willing to nurture, willing to support every single one of these GPUs in the world because they're all architecturally compatible. We're willing to do so because the install base is so large. If we release a new optimization, it benefits millions. This applies to everybody in the world. This combination of dynamics is what makes the NVIDIA architecture expand its reach, accelerating its growth, at the same time driving down
この辺
computing
は
costs,
NVIDIA のアー
which
キテクチャがど
ultimately
んどんなんか進化してるよとか、いい、
So
なんだろうな、
CUDA
フィー
is
ドバ
at
ッ
the
クを回して
center
る
of
よとか、そういう感じのこと言って
But
る
our
ね。
journey, the
エコ
CUDA
システム
actually
に対して
started 25 years ago.
お、
GeForce,
なんかだんだん世代の GTX 出し
I
た
know
の
how
か
many
な。
of you grew up with GeForce. GeForce is NVIDIA's greatest marketing
あ、どう
campaign.
も、おつわりです。
We
みんな早起きだね。
attract future customers starting long
ま
before
あ、
you could afford
5090
to pay for it
ね。まだい
yourself.
いな、欲しいけど
Your
な、
parents
高いんですよね、この子。
Your parents paid. Your parents paid for you to be NVIDIA customers. And every single year, they paid up year after year after year until someday you became an amazing computer scientist and became a proper customer, a proper developer. But this is the house that GeForce made. 25 years ago, we started our journey, which led to CUDA. 25 years ago, we invented the programmable shader, a perfectly unobvious
25年前にプログラ
invention
ムシェーダーを
to
出してか
make
らっ
an
て話をしたよね。
accelerator
クーダが話した
programmable,
ね。
the world's first programmable accelerator, the pixel shader. 25 years ago, that led us to explore further and further. 20 years later, 5 years later, the invention of CUDA. One of the biggest
メ
investments
モ
that
リ
we
増
made,
強モデル出しても需
and
要
we
が
couldn't
少ない
afford it
は
at
て
the
な。
time. And it
メモ
consumed
リ
the
増強モデルの
vast
需要は
majority
多
of our
分ね、コン
company's
シューマー向
profits
けにあるとは
was
思うん
to
だけ
take
ど、
CUDA on the backs of GeForce to every
どこま
single
で今
computer.
そういう市場を狙おう
We
としてるかがよ
dedicated
くわか
ourselves
んない
to
んだよ
create
ね。
this platform because we felt so strongly about its
ハイエン
potential.
ドとミドルエンド
But
だけ狙ってる
ultimately,
ようにも見えなくもないし
the
ね。まだ
company's
ね。
dedication to it,
外付けで増
despite
設できる
the
ようにして
hardships
ほ
in the
しい。
beginning, believing in every single day,
CXL っていう企画が今ね、まさに出ていて、
13 generations of
CXL2 を
20
使う
years,
と外付
we
けで
now
増
have
設できるん
CUDA
だよね。だ
installed
からもう
everywhere.
ちょっと待つ
The
と、
pixel shader
その辺の技術がコンシュー
led
マーにも
to,
落ちて
of
くると思うん
course,
だけ
the
ど、
revolution of GeForce.
多分でもね、
And then 10 years
2000
ago, we introduced, about 10 years
28、
ago, what is it, 8 years ago?
まあ、
We introduced
2029年から30年
RTX,
だね。その辺がデスクトップに落ちてくるの。まだサーバーサイドでもうまく
for
いって
the
ないから
modern
ね。
era of computer graphics.
CXL 系は。すご
GeForce
い私
brought
も気に
CUDA
して
to
る
the
んだけど
world.
さ、CXL。
GeForce
とある
therefore
AI。
enabled Alex Khrushchevsky and Ilya Sutskever and Jeff Hinton, Andrew Ng, and so many others
そうそう、ロ
to
ーカル AI もね、
discover
賢くなってきたしね
that。the GPU could be their friend in accelerating deep learning. It started the big bang of AI. 10 years ago, we decided that we would fuse
10年前に何を決めたの？
programmable shading and introduce two new ideas. Ray tracing, hardware ray tracing, which is incredibly hard to do.
今だと
And the new
GPT-3
idea
レ
at
ベ
the
ルしか
time,
動かないから。
imagine about 10
いや、
years
結構ね、
ago, we
GPT-4 レ
thought
ベル
that
もう動き
AI
ます
would
よ。
revolutionize computer graphics.
だいぶ賢くなった。
Just
クエン
as
3.5 とかね、
GeForce
相
brought
当賢
AI
い。
to the world, AI is now going to go back and revolutionize how computer graphics is done all together.
まあ
Well,
16
today
ギ
I'm
ガ
going
ぐ
to
らい
show
は
you
欲しいけど
something
ね
of the
メモリ
future.
そう
This
や
is
っ
our
て
next generation of graphics technology. We call it neural rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS5. Take a look at it.
3D グラフィックスと AI をフュージョンって言ってるから DLSS 的な話をするのかな。やっぱそうだね。お DLSS5? すげえ。いや DLSS っていうのはNVIDIA が今作ってる AI を使ったグラフィックをエンハンスする機能なんだけども、なんかね、エンハンスするって考えると多分もうちょっと違っていて、基本的にね、超低解像度でレイトレーシングで一回画面を作って、それをね、高画質化するような技術なんだよね。で、これ何がいいかっていうと、まあ、さっきね、多分、ちょっと聞き流したところで言ってたんだと思うんだけど、昔はもともともう全部 3D グラフィックス自体を作るために、GPU がね、一番仕事をしてきたんだけども、これからね、さっきのフュージョンっていうのはそうだと思うんだけど、3D グラフィックス自体を AI でどう進化させるか。つまり AI 向けに強化したテンソーコアとかのチップが最終的に 3D グラフィックスも生きていくんだよっていう世界観を今 NVIDIA は構築しているんだよね。その肝が DLSS で、この5っていうの最新バージョンですね。おー、これはいいね。
Computer graphics comes to life. Now, what did we do? We fused controllable 3D graphics, the ground truth of virtual worlds,
全然違う。
the structured data.
ね、めちゃめちゃ画
Remember
質が
this
綺麗。
word, the structured data of virtual worlds, of
持ってない。
generated worlds. We
いや、多
combine
分持って
3D
はないと思うよ。
graphics, structured data
まあ、
with
5090がいるけ
generative
ど。
AI, probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly realistic. We combine these two
サイバ
ideas,
ーパンクのゲームは稀有な
combine
表
these
現で
two
きてな
ideas,
かったハテナ。
control through structured data,
あ、そこまで行くんですね。プレイはしてないから
perfectly,
わかんないけど、
and yet
ありえますね、それぐら
generating
い。
at the same time. And as a result, the content is beautiful, amazing, as well as controllable. This concept of fusing structured information and generative AI will repeat itself in one industry after another industry after another industry. Structured data is the foundation of
ストラク
trustworthy
チャーデ
AI.
ータが、まあ、
Well,
なんだろうな。多分、
this
計
is going
算
to
で
scare
求
you a
まる
little
デー
bit.
タっていう
I'm
の
going to
が、
flip the slide.
ベースにあっ
And
て、
don't
それと
gasp.
AI を組み合わせることで、まあ、より発展させるみたいな
So
ことを
we're
言
going
って
to
るよう
go
な
through
雰囲
this
気がするな。
schematic
ちゃん
for
と
the
聞きたか
rest
った
of
け
the
ど。
time.
ちっちゃいの出てきた。な
This
んだ
is my best slide. Every time I ask the team,
Nanda
what's my
kono
best
pipeline wa.
slide? Repeatedly, this was it. They say, don't do it, Jensen. Don't do it. I said, no. These seats are free
わかんないね。
for some of you. So this is your price of admission. So this is structured data. You've heard of it. SQL, Spark, Pandas, Velox, some of these really, really important, very large platforms. Snowflake, Databricks,
だから、
EMR,
やばい、あれ
Amazon
かな。実
EMR,
際の現実のデータね、ストラクチャー
Azure
データって
Fabric,
言ってるのは、も
Google
う、スノー
Cloud,
フレークがどうだとかで言ってるから、普通にまあ、
all of these platforms are
なんだろうな、サ
processing
ーバー
data
とかデー
frames.
タベー
These
スに
data
入って
frames
る、
are
あるいはドキュメン
giant
トとかも多分入れてるん
spreadsheets,
じゃないかな
and。they hold all of life's information. This is the structured data, the ground truth of business. This is the ground truth of enterprise computing. Well, now we're going to have AI use structured data, and we better accelerate the living
スト
daylights
ラ
out
ク
of
チャー
it.
データがまあ
It
ベー
used to
ス
be
にあって、そ
okay,
れ
and
を、
we would, of course,
AI が
we
ね、
would
どんどん使っ
accelerate
ていくよって話をして、まあ
structured
この辺は
data
よ
so
く
that
言わ
we
れる
could
話だよ
do
ね。まあ
more,
ビッグ
we
デー
could
タ
do
っ
it
ていう
more
言葉が出
cheaply,
て以
we
来
could do
の
it more
まあデ
frequently
ータ
per
は結構
day
ね、
and keep the company running
王様だっ
at
て
a
いう
much
話を
more
ずっと言ってるか
synchronized
ら、まあ
way.
その文脈の話を
However,
して
in
る
the
かな。
future, what's going to happen is these data structures are going to be used by AI, and AI is going to be much, much faster than us. Future agents are going to use structured databases as well. And then, of course, the unstructured database, the generative database. This database represents the vast majority of the world. Vector databases, unstructured data, PDFs, videos, speeches,
あー、あれ
all
か。
of the world's
アン
information,
ストラクチ
about
ャーデータとか、まあ普
90%
通
of
にド
what's
キュメン
generated
トだ
every
とかの
single
ことを
year
アンストラクチャー
is
データって言いますね。
unstructured data. Until
きベク
now,
タル DB
this
っていう
data has
話
been
もしたけど、ベ
completely
クタル
useless to
DB
the
は
world.
そ
We
のも
read
の
it,
が
we
アンス
put
トラ
it
クチャ
into
ー
our
という
file
より
system,
は、
and that's it.
アンストラクチャーデー
Unfortunately,
タ
we
の
can't
格の方
query
式だ
it.
ね、
We
ベク
can't
トルは。
search for it. It's hard to do that. And the reason for that is because there's no easy indexing of unstructured data. You have to understand its meaning, its purpose. And so now we have AI do that. Just as AI was able to solve multi-modality perception and understanding, you can use that same technology, multi-modality perception and understanding, to
マ
go
ルチ
read
モ
a
ーダリティって言い
PDF,
方
to
をしてるか、
understand
まあ
its
画像
meaning.
とかね、
And
映像
from
と
that
か音声とか
meaning,
テキストだけじゃなくて、
embed
複
it
数の
into a larger structure that
まあ
we
コ
can
ンテキスト
search
というか、
into,
複数
we
の
can
メディアを
query
取り扱
into.
うことができる。
NVIDIA created two foundational libraries, just like we created RTX for 3D graphics. We created CUDF for data frames, structured data. We created CUVS for vector stores, semantic data, unstructured
QDF ってい
data,
う、まあ、デ
AI
ータフレ
data.
ーム、
These
まあ、ビッ
two
グデータとかで使われ
platforms
るデ
are
ータ、
going to
構
be
造データの解
two
析
of the
型で
most
すけど、デ
important
ータフレーム
platforms
の
in the
対応した
future.
ものと、
Super excited to see its adoption
QVS、
throughout the network, this complicated
vector
network of the
形式
world's data
まあ、なの
processing
で、
systems.
さっき
And the
の
reason
画
for
像
that
だ
is
とか
because
音
data
声だとかド
processing
キュ
has
メン
been
トとかね、
around a
こういった
long
もの
time.
の、
And therefore,
ベクトル化してインデッ
so
クス化
many
するのに
different
構造化した2
companies
つの
and
ライブラリを、
platforms and
ネイティブ
services.
で作ってい
It
ま
has
すよというこ
taken
とを
us a
言って
long
ますね。
time to
まあ、ソフト
integrate
頑張ってるよって
deeply
いう話。
into
データを
this
使うのは
ecosystem. I'm
構造化
super
データ
proud
も
of the work that
構
we're
造化
doing
データ
here.
もどっち
And
も
then
NVIDIA
today,
が頑張ってると。
we're announcing several of them. IBM, the inventor of SQL, one of the most important domain-specific languages of all time, is accelerating Watson X data with CUDF. Let's take a look at it.
なんか IBM と組んで何かやったの
60 years ago, IBM introduced
ま
the
あ
system
データベース作った
360,
会社って言ったら IBM だからね。
the first modern platform for general-purpose computing, launching the
これ
computing
メ
era.
インフレームだね、いわゆる。
Then SQL, a declarative language to query data without requiring the computer to be instructed step by step. And the data warehouse, each the foundations of modern enterprise computing. Today, IBM and NVIDIA are reinventing data processing for the era of AI by accelerating IBM Watson X data SQL engines with NVIDIA GPU computing libraries. Data is the ground truth that gives AI context and meaning.
GPU ベースのデータベ
AI
ー
needs
スを
rapid
IBM と一緒
access
に
to
作りました
massive
よって
data
感
sets.
じの話かな。
Today's CPU data processing systems can't keep up.
まあ、通常の
Nestle
CPU、
makes
GPU、
thousands of
デ
supply
ータベー
chain
スは CPU ベース
decisions
だね。
every day. Their order to cash data mart aggregates every supply, order, and delivery event across global operations in 185 countries. On CPUs, Nestle refreshed the data mart a few times a day. With accelerated Watson X data running on NVIDIA GPUs, Nestle can run the same workload 5 times faster at 83% lower cost.
5倍
The
早
next
くて
computing platform has arrived. Accelerated
15%
computing
の消費電力
for the era of AI.
まあ GPU を使った、RDB 自体はね、いくつかあるんだけどね。
NVIDIA accelerates data processing in the
PG
cloud.
Storm
We
とか
also
日本人も作ってるね。
accelerate data processing
それを NVIDIA は
on-prem.
ネイティブでやっ
As
て、
you know,
IBM と
Dell
組んで
is
やってる
the
のはちょっと面
world
白い
leading
かもしれない
computer
ね。
systems maker, and they also are one of the world's
デ
leading
ータエンジン
storage
はスパーク
providers,
とか
and
使
they
っ
worked
て
with
る
us to
か
create
ら、まあ
the
でもこれ
Dell
前からあるよ
AI
うな気が
data
するね。
platform that integrates
でも今
CUDF
回の
and CUVS
新しい
to
ものという
create
よ
an
りは、まあチューニング
accelerated
したか
data
リブランディングし
platform,
たからね。
well, for the era of AI. And this is an example of what they
ス
did
パ
with
ークで
NTT
GPU
data.
は昔から
Huge
使えるん
speed
だよね。データ分
This
析
is
として。
cloud, Google Cloud. And Google Cloud, as you know, we've been working with Google
ハイ
Cloud
パー
for a
コン
very
ピュー
long
ティングにも
time.
QDF が入ったの
We accelerate Google's Vertex AI. We now accelerate BigQuery, really important framework and really important platform. And this is an example of our work together with Snapchat, where we reduced their cost of computing by nearly 80%. When you accelerate
すごいね。
data processing, when you
76% のコ
accelerate
ストセービン
computing,
グ。めちゃめちゃ
you
圧
get
縮
the
されてる。
benefit of speed, you get the benefit of scale. But most
スナッ
importantly,
プチャ
you also
ッ
get the
ト
benefit
と、
of
Google
cost.
と NVIDIA の
And
事
so
例と
all of
して、
those come together
デ
as
ータ
one.
解
It was
析を、
originally
まあ、
called
その
Moore's
分だけ
Law.
圧縮できたって
Moore's
話
Law
だね。
was about
CPU ベー
getting
スのアーキテクチャ
performance
ーから GPU ベー
doubling
スに
every couple of years. It's another way of saying So long as the price remains about the same
まあ
and
それ
most
は
computers
あり得るよ
remained
ね、十
about
分。
the same, you're also getting twice the performance
GPU は
every
ね、め
year,
っちゃ高い
or
けど、お値段的にめっちゃ
reducing
高い
the
けど、
cost
そ
of
の分性
computing
能も
every
ね、う
single
まく
year.
使いこなすと
Well,
CPU よりず
Moore's
っといい
law
から、
has
コ
run
スパが
out
高
of
くないこ
steam.
とは当然ある。
We need a new approach. Accelerated computing allows us to take these giant leaps forward. And as you will see later, because we continue to optimize the algorithms, and NVIDIA is an algorithm company, as we continue to optimize the algorithms, and because
NVIDIA アルゴリズム
our
ね、
reach
計
is
算
so
方法めっ
large
ちゃ
and our
頑張ってるよ
install
って言
base
って
is
るね。
so large, we
まあ
can
単なる
reduce
ハー
the
ドウェアさんじゃ
computing
ねえと。
cost,
アルゴリズムカンパニー
increasing
で
the
すからね。
scale, increasing the speed for everybody continuously. This is Google Cloud. You could see this pattern I just mentioned. I just wanted to show you 3 versions of it. NVIDIA built the accelerated computing platform. Has a bunch of libraries on top. I gave you 3 examples. RTX is one of them, CUDF is another, QVS, and we'll show you a few more. These libraries sit on top of our platform. But ultimately, we integrate into the world's cloud services, into the world's OEMs, and together, and other platforms that I'll show you, together we're able to reach the world. This pattern, NVIDIA, Google Cloud, Snapchat, will repeat over and over again, and it kind of looks like this. And so this is one example, NVIDIA with Google Cloud. We accelerate Vertex AI.
どうやっ
We
てシス
accelerate
テムとしてイン
BigQuery.
テグレートす
We
るかが大事な
accelerate.
時の話をしてるかな。
I'm super proud of the work that we've done with JAX and XLA.
GCP との
We're
連携の
incredible
スナッ
on
プチャットの事
PyTorch.
例。
We're the only accelerator in the world that's incredible on PyTorch and incredible on JAX and XLA. And the customers that we support, the Base 10s, the CrowdStrikes, Puma, Salesforce, they're not our customers, but they're customers, developers of ours that we've integrated the NVIDIA technologies into that we can then land on the clouds. Our relationship with cloud service providers are essentially us bringing customers to them.
今回結構、
We integrate our
Google と仲良し
libraries, we accelerate workloads, and we land those customers in the clouds.
結構
And
年によって
as you can
AWS と
see,
の連携の話するとき
most
と
of our
か、
cloud service providers love working with
Azure との
us,
話するときとか、なんか
and
若干違う気
they're
がするけ
always
ど、
asking us
まあ
to land
僕
the
たちずっ
next
ともだよ
customer
ねって
on
みん
their
なに言ってる
cloud.
感じだね。
And I just want to let you know, there are a lot of customers. We're going to accelerate everybody. And so there'll be lots and lots of customers who will be able to land in your
い
cloud.
ろんなね、
Just
カ
be
スタマーを
patient
どん
with
どん
us.
ね、アク
And
セレ
so
ー
this
ト
is
が、
Google Cloud.
エン
This
カ
is
レッジさせたいんです
AWS.
ね
We've。been working with
言って
AWS a
ます
long
ね。
time.
あ、
And
AWS
one
み
of
た
the
いな。
areas, one of the things I'm super excited about
GCP
this
だけじゃ
year
ないと。
is
AWS
we're
もちゃ
going
ん
to
とア
bring
クセレートしてるよ。
OpenAI to AWS. And so it's going to drive enormous consumption of cloud computing at AWS. It's going to expand the reach and expand the compute of OpenAI. And as you know, they are completely compute constrained. And so
OpenAI
AWS, we accelerate EMR, we accelerate SageMaker, we accelerate Bedrock. NVIDIA is integrated really deeply into AWS. They were our first cloud partner. Microsoft Azure.
当然
NVIDIA's
Azure でもありますよと。
A100 supercomputer was the first one we built was for NVIDIA. The first one we installed was at Azure. And that led to the big successful partnership with OpenAI. But we've been working with Azure for quite a long time.
あ、違う
We
な、OpenAI 最
accelerate
初に言った会社って言ってた
Azure
のかな。
Cloud. Now it's their AI Foundry we partner deeply with. We accelerate Bing Search. We work with them
オラクルク
on
ラウドはここに
Azure
登場できるんですか
regions.
ね。
This is one of the areas that is incredibly important as we continue to expand AI throughout the world. One of the capabilities that we offer is confidential computing.
あー、コンフィデンシャルコンピュ
In
ーティングね。
confidential computing, you want to make sure that even the operator cannot see your
ね
data.
コンフィデン
Even
シ
the
ャルコンピューティング、
operator
機密コンピュー
cannot
ティングって
touch
いう
or
話を
see
今して
your
いて、
models. Confidential
それはね、
computing, NVIDIA's GPUs is the first ones in the world to do
まあ
that.
仮想化とかをし
Is
たとき
now
に、
able to
まあい
support
ろんな定義
confidential
があるんだけど、
computing and
実際
protected
今説明してる
deployment
のは、
of these very
仮
valuable
想化とかを
OpenAI
したとき
models
に、その
and
ベン
Anthropic
ダー側
models
が
throughout
我々が実
clouds
際
and
ね、処理したいデ
different
ータを見る
regions,
こと
and
ができない。
all because of our confidential computing.
そういうもののこ
Confidential
と言ってるか
computing
な。
is super important. And here's an example
暗号化した
where
ま
we
ま
have
データ
different
を処理す
customers
るって
that
いう
we
のは
work with.
コンフィデンシャルコンピュー
Synopsys,
ティング
a
って言うん
great
だけど、
partner of ours, we're accelerating
その
all of
機
their
能をね、
EDA and
こ
CA
こ最近
workflows.
オンプレじゃな
NVIDIA
くてもよくなるね。
At Microsoft Azure. We were Oracle's first AI
お、
customer.
すごい、オラクルも登場したじゃん。
Most people would have thought we were
まあ、オンプレ
their
じゃな
first
くてよくなる
supplier.
っていうのは
We're
そうい
their
うことで
first
すね。
supplier also. but we were their first AI customer. I'm quite proud of the fact
オラク
that I
ルクラウド
explained
がね、
AI
なんかこうい
clouds
った4大
to
クラウ
Oracle
ドとし
for
て
the
ね、
first
ちゃんと
time.
紹介され
And
るよう
we
になっ
were
た
their
のは少し
first
感慨
customer.
深いですね。はい。
Since then, they've really taken off. We've landed a whole bunch
結
of our
構素
partners
直で、
there.
性能的にはね、素直でね、
Cohere and
私は
Fireworks
嫌
and
い
of
じゃないん
course,
だけど、
very
ユーザーイン
famously
ターフェース
OpenAI.
がゴミということ以外はね、素晴らしいクラウドだと思う
Great
よ。
partnership with CoreWeave.
は
They're the
コー
world's
ウィーブね。
first
これは
AI
ネオクラウドっ
native
て言われてるね、ちょっと
cloud.
別なジャンルです
A
ね。
company that was built with only one singular purpose: to provision, to host GPUs as the era of accelerated computing showed up, and to host for AI clouds. They've got some fantastic customers, and they're growing incredibly.
彼ら
One
は、
of the platforms that I'm quite excited about is
たった一
Palantir
つの
and
目
Dell.
的、
The three of our
GPU をホス
companies
ティングして
have made it
AI を
possible
加
to
速させ
stand
るこ
up
と
a
だけを目
brand
的に
new
したク
type
ラウドだ
of
っていう説明を
AI
さっきしました
platform,
ね。
the
これをネオクラウ
Palantir
ドという形
Ontology
です。
platform, an AI platform. And we
CoreWeave
can
はその
stand up
中でも
these
かなり、
platforms in any
す
country,
ごい
in
一番
any air
目立ってい
gapped
るような会社
region,
かな。
completely on-prem, completely
こ
on-site,
れはオンプレ
completely
ミス
in
で
the
デルと
field.
かと組んでやる
AI
話を
could
して
be
るのかな。
deployed literally everywhere. Without our confidential computing capability, without our
オン
ability
プレミ
to
スで今やる
build
のはね、
an
結構お
end-to-end
すすめ
system,
しづ
as
らい
well as
か
offer the
な。
entire
よっぽどね、
accelerated
金があ
computing
る
and AI stack, from
ところ
data
は別なんです
processing,
けど
whether it's
も、そうじゃ
vectors
な
or
いと、
structures, all the way to AI,
それこそ
it
多分
wouldn't have
今
been
日話される
possible.
であろうね、DGX とかね、
I
もう
wanted to
デ
show
ー
you
タセン
these
ターレベル、
examples.
ラックレベルでカスタマイ
This
ズされ
is
てるから、
our
なんか
special
一
working
個、ちょっ
relationship
とね、GPU のサー
with
バーを
the
2、3
world's
台入れて
cloud
とかじゃ
service
ね、追
providers.
いつかないん
And
だよ
many, well,
ね。
all of them
コ
are
スパの
here.
面で。
And I get the
そうやったら
benefit
クラ
of
ウド使
seeing
った
them
方がいい
during
かもみ
booth
たいな
tour,
文脈にな
and
っ
it's
ちゃうんだ
just
よ
so
ね。
incredibly exciting. I just want to thank all of you for the hard work. What NVIDIA has done is this, and you're going to see this theme over and over again. NVIDIA is vertically integrated, the world's first vertically integrated but horizontally open company. And the reason that's necessary is very simple. Accelerated computing is not a chip problem. Accelerated computing is not a systems problem. Accelerated computing has a missing word.
まあ、
We
チッ
just
プ
never
と
say
か、
it anymore.
まあ、システムのレベルの
Application
問
acceleration.
題ではないと。
If I could make a computer run everything faster, that's called a CPU. But that's run out of
お、
steam.
CPU の端来たか
The
らベラ
only
の端来
way
るんじゃ
for
ない？
us to accelerate applications
ベ
going
ラっていうの
forward
はね、
and continue
NVIDIA が
to
作ってる
bring
ARM ですよ。
tremendous speed up, tremendous cost reduction
新しいのが出るは
is
ずだから。
through application or domain-specific acceleration. I dropped that phrase in the front, and therefore it just became accelerated computing. And that is the reason why NVIDIA has to be library after library, domain after domain, vertical after vertical. We are a vertically integrated computing company. There is
垂
no
直
other
統合、
way.
NVIDIA は
We have to
もうパー
understand
ツ
the
パーツじゃなくても
applications,
垂
we
直
have
統
to
合し
understand
て、
the domain, we
も
have to
う
understand
CPU もやる
fundamentally
し、
the algorithms,
GPU もやる
and we
し、
have to figure
垂
out
直
how
統合
to
していく会社なんだよ。
deploy
ライブ
the
ラリもいっぱい作って
algorithm
るよってことを言ってるね。
in whatever scenario it wants to be deployed, whether it's a data center, cloud, on-prem, at the edge, or in a robotic system. All of those computing systems are different. And finally, the systems and chips. We are vertically integrated. What makes it incredibly
まあロボット
powerful, and the
と
reason
か
why
サ
you
ーバー
saw
だ
all
と
the
かいろんな
slides
分野がある
is
けど、
because
それを
NVIDIA
もう
is
垂直統合します。
horizontally open. We'll work and integrate NVIDIA's technology into whatever platform you would like us to integrate into. We offer you the software, we offer you libraries, we integrate with your technology so that we can bring accelerated computing to everybody in the world. Well, this GTC is really a great demonstration of that. You know, most of the time you'll see me
も
talk
う来
about
ま
these
したね。いろいろやっ
verticals, and
ぱ
I'll
フィ
use
ジ
some
カル
examples.
AI の
But
話
in
がやっ
every
ぱ出てくる
single
よね。
case, whether it's automotive,
まあ、オート
by
モ
the
ビ
way,
ルからファイ
financial
ナンシャル
services,
サービス、
the
ヘルス
largest
ケア、
percentage of attendees at this GTC is from the financial services industry.
量子コンピューター、
I know.
リテール、
I'm hoping it's
流通ね。
developers, not
でロボティ
traders.
クス、テレコム、電話系。
Guys,
なんかマイクを、イヤホンがずれたかな。
here's one thing I wanted to say. And so, in the audience represents NVIDIA's ecosystem upstream of our supply chain and downstream of our supply chain. And we think about our supply chain upstream and downstream.
まあ、ア
And
ップ
it's
ス
just
トリームも
so
ダウンストリーム
exciting
もサプライチェーンもうちの顧客だと。
our entire upstream supply chain this last year Irrespective of whether you're a 50-year-old company, we have 70-year-old companies, we have a 150-year-old company who are now part of NVIDIA's supply chain and partnering with us either upstream or downstream. And last year, you had your record year. Did you not? Congratulations.
ラストイヤーはなんかレコードイヤーだっつってるね。なんかコングラチュレーションされた。
We're on to something here. This is the beginning of something very, very big. And so, if you look at accelerated computing, we've now set the computing platform, but in order for us to activate those computing platforms, we need to have domain-specific libraries that solve very important problems in each one of the verticals that we address.
やっぱそれぞれの産業にあったドメインスペシック、やっぱ業界に応じたライブラリを作っていくことが重要だっていうことを今言ってるね。
Our impact incredible. We have a track on that. Financial services I just mentioned. Algorithmic
そうなんだよ
trading
ね。
is
やっ
going
ぱ
from
車向けのライ
classical
ブラリとか、
machine learning
ファイナンシャル向けのライブラリ
with
ってもちろん
human
違うからね。
feature
ファンダメンタルライブラリだけじゃなくて、そういったドメインスペシフィックなライブラリも NVIDIA 頑張ってますよって言ってるし、確かにね、今までもそういう発表たくさんやってきたよね、毎年。そこが強いよね、やっぱ NVIDIA。ちゃんとインダストリーに特化したものを出せてるっていうのはね。
is going through their ChatGPT moment. Some really exciting work that we're there. We have a great keynote track here. We have a great keynote track. Kimberly Powell's doing a great keynote track for healthcare. We're talking about
そろそろこけてほし
AI
い。一興に
physics
不
or
安を
AI
覚える。
biology for drug discovery.
まあ、
AI
一
agents
興に
for
不安を
customer
覚える気持ち
service
もわかるし、まあ
and
AMD がね、
of
追いつけ追い
diagnosis
越
and
せで性能的には
diagnosis. And
頑
of
張ってる
course,
し、まあ
physical
その文脈
AI,
だと Google の
robotic
TPU と
systems.
かもあるんだけど
All
も、
these different vectors
NVIDIA の
of
強さっ
AI
て、
have
まあキン
different
グメーカー
platforms
的な
that
要素は
NVIDIA
もちろんあ
provides.
るんだけど、今となって
Industrial.
は。
We are
やっぱこの
completely
ドメイン
resetting
をちゃん
and
と抑え
starting
てるこ
the
と
largest
だ
build
と思うん
out
ですよね。
of
産
human
業
history. And
を抑えて、
most of the world's
ちゃんと
industries
広げようとしてるか
building
ら
AI、factories, building chip plants, building computer
そう
plants
簡
are
単にはこけづ
represented
らいよ
here
ね。
today. Media
まあ
and
自動
entertainment,
車か
gaming
な、
of course,
次の、
real-time AI
タ
platform
ーニングポイント
so
は。
that we could translation and broadcast support and live games and live video. Enormous amount of it will be
なんか
augmented with
NVIDIA
AI.
神話をね、
We have a
言うわけじゃないけ
platform
ど、
called Holoscan.
結構ポート
Quantum,
フォリ
there
オと
are
か戦
35
略やっぱ
different
強いな
companies
っていつ
here
もね、GTC 毎
building
年見
with
てる
us
から思うん
the
だよね。
next generation of quantum GPU hybrid systems, retail and CPG,
まあ量
using
子コンピュ
NVIDIA
ータ
for
ーも、まあ
supply
GPU の
chain,
ハイブリッ
using
ドでいくっていうこと
creating
も言ってる
agentic
し、まあ、そこ
shopping
が
systems,
どうなるかですよね、まあ
AI
実際。
agents for customer support. A lot of work being done here. $35 trillion industry. Robotics, $50 trillion industry in manufacturing. NVIDIA's been working in this area for a decade now, building 3 computers, the fundamental computers necessary to build robotic systems. We are integrated with, working with literally every single company that we know of building robots. We have 110 robots here at the show. And then telecommunications. About as large as the world's IT industry, about $2 trillion. We see, of course, base stations everywhere. It's one of the
これだ
world's
けの産業に入り込めるっていう
infrastructures.
のは
It
ね、やっ
was the
ぱ
infrastructure of the
10年前
last
のね、ゲー
generation
ム
of
が中心っ
computing.
て言ってた、まあ10
That
年、もっと15
infrastructure
年ぐ
is
らいか
going to
な。
get
15
completely
年前のね、ゲーム
reinvented.
が中
And
心
the
って言
reason
っ
for
て
that is
た、
very simple.
まあ NVIDIA から
That
想像もで
base
きない姿
station,
です
which
よ
is
ね。うん。
it does one thing, which is base station. It's going to be an AI infrastructure platform in the future. AI will run at the edge. And so lots of great,
AI がまあエッ
great
ジで動くって
discussion
言
there.
っ
And
て
our
て、
platform
まあ、さ
there
っ
is
きテレ
called
コムの話をしてたか
Ariel,
らかな。
our AI
モ
RAM.
バイルネッ
Big
トワーク
partnership
上
with
で、
Nokia, big
AI と
partnership
かは
with
ね、
T-Mobile and many
動
others.
かすことが今後増えてきて、まあ、それを
At the
GPU
core
フ
of
ァーム
our
を使ってや
business,
るっていう話は確かによく聞
everything
き
that
ま
I
す
just
ね。
mentioned, computing platforms, but very importantly, our CUDAx libraries. Our CUDAx libraries is the algorithms that NVIDIA invents. We are an algorithm company. That's what makes us special. That's what makes it possible for me to be able to go into every single one of these industries, imagine the future, and have the world's best computer scientists
まあ、ドメインスペシフィ
CUDA は
ック
独禁法で開放させないといかん。
re-express it
でもね、
and turn it
CUDA
into a library. We have
を
so
独禁法で
many.
開放したからといって、あんまり意味
At
ないん
this
です
show,
よ。
we're announcing 100
CUDA をね、仮にオープンソースにしたからといって、NVIDIA はね、多分そんな致命的に困らないんですよね、
and
正
that's
直
just
言う
at
と。
the show. We're
なぜな
updating
らあれ
these
は
all the
NVIDIA の
time.
ハードウェア
We're
を
updating
高
them
性能
all
に
the
動か
time.
すた
The
めの
libraries is
API に
the
過ぎなく
crown
て、
jewels
でそれは、例えば Google だとか AMD とか、そんなに簡単に活用できるものではないんですよね。特に CUDA のフ
ク
ァンダメン
ロームも
タルとかね。
作れるけどライセンスで使えないって AMD が言ってる。
ライセンスで使えないとかあるのかなっていうのが、どうなんだろうね。CUDA 互換を作ることはできると思うんだけど、
20 years ago, we
そ
built
れだけ
CUDA,
だとそんなに
a
AMD 的
single
な美味しさがない
architecture
から
for
ね。
accelerated computing. Today, we've reinvented computing. 1,000 CUDAx libraries help developers make breakthroughs in every field of science and engineering. CUDAX for
CUDAX ライバリー
decision
ってだと今年
optimization.
はなんかすごく言ってますね。
CULitho for computational lithography.
単純に速い遅いっていうよりは、
CUDSS
アルゴリ
for
ズムとか
direct
ドメイ
sparse
ンとかの話を
solvers.
強調してるから、CUDA のエコシステムの
For
広さを言って
geometry
るね。
aware neural networks.
うんうんうん。
Aerial for AI
こっちが
RAM.
結構CUDA タイルとか含めてソフトウェア的な話
Warp
が
for differentiable
強い
physics.
かもね、特に前面は。
Parabricks for genomics.
単なる CUDA っていう
At their foundation
ファンダメンタルの
are
ライバリの話じゃなくて、
And they are beautiful.
どういう個別ライブラリ、例えば CUDA を使った何らかの計算を早くするライブラリとか、CUDA を使った、車だとか、そのファイナンシャル向けのライブラリとか、それからそういう個別の要素を我々はしっかり取りに行ってるんですよっていうことを強調しているから、CUDA ウォールがあって、CUDA ボートがあって、そのエコシステムで我々はうまくいってるんだっていう、なんか、汎用的な話というよりは、もっと具体的なところも我々やってるんですよっていうのを強調しているような感じですよね、今年は。いつも言ってるっちゃ言ってるんだけど、特に言ってるイメージはある。CUDA もね、CUDA っていうと、例えば NVIDIA の、AMD に6カメラって、多分ね、単純性能面で言うと CUDA にそんなに今引けを取ってないんだと思うんですよね。でも、CUDA はすでにこのなんとかっていうライブラリをたくさん、公式で NVIDIA も出してるし、オープンソースで、CUDA を前提に最近化したライブラリもたくさんあって、そこのエコシステムが強いんですね。CUDA のね、なんかそのファンダメンタルな計算モデルというよりは、多分 CUDA を前提にしたライブラリがすごく多くて、もうちょっと NVIDIA のハードウェアを前提にしたライブラリが結構強い。CUDA の、ソフトウェア的な表現能力とか、ケーパビリティとかで、ロッカムが大幅に負けてるわけでは全然なくて、どちらかというと、その CUDA を、あるいはその先にある NVIDIA のハードウェアを前提にしたソフトウェア群が大量にあるから、そこが、参入しづらいねっていうか、参入商品になってるわけですね。CUDA がオープンソースになったからって劇的にね、AMD がソフトウェア的に巻き返せるかというと、そういうわけではないんじゃないかなと私は思いますね。これはあれかな、コスモスの映像な気がしますね。NVIDIA のワールドモデル。アース2ね。すごいよね。アース2。第2の地球という名前の計算モデルを NVIDIA は持ってますからね。これは地球シミュレーターみたいなものだけど。
Some of it was principle solvers, fundamental physics solvers. Some of it was AI surrogates, AI physical models. And some of it was physical AI robotics models. Everything was simulated. Nothing was animated. Nothing was articulated. Everything was completely simulated. That is what fundamentally NVIDIA does. It is through the
シミュレーション自体の AI によるアクセレートもしているという話をしているのかな。
that we're able to open up to unlock these opportunities. NVIDIA is a vertically integrated computing company with
いわゆるロボットとかね、自動運転ですけど、phygics for AI って言い方をすると、物理世界のための AI みたいなのがあって、実際の科学技術計算とかを AI によって加速するっていう考え方があるんですよね。
incredible
今まではめちゃくちゃ重いシミュレーションしないといけなかったところを
JP Morgan and Roche.
GPU で補うんだよね。多分その話をしてそうな気がするな。
Companies that have defined society to today. Toyota is here. These are some of the largest companies in the world. It is also true that there's a whole bunch of companies you've never heard of. These are companies, we call them AI natives. A whole bunch of small companies. The list is gigantic. I couldn't, this is just a little tiny bit of it. And I couldn't decide whether to show you more or show you less. And so I made it so that you couldn't see any. And nobody's feelings are hurt. However, inside this list are a bunch of brand new companies. There are companies like, for example, you might have heard a couple of them, OpenAI, Anthropic, but there's a whole bunch of others. There's a whole bunch of others, and they serve different verticals. Something happened in the last 2 years, particularly this last year. We've been working with the AI natives for a long time, and this last year, it just skyrocketed. I'll explain to you why it happened. This industry has skyrocketed. $150 billion of investment into venture investment, into startups, the largest in human history. This is also the first time that the scale of the investments went from millions of dollars, tens of millions of dollars, to hundreds of millions of dollars and billions of dollars. And the reason for that is this is the first time in history that every single one of these companies needs compute, and lots of it. They need tokens, lots and lots of it. They're either going to create and build and create tokens and generate tokens, or they're going to integrate, add value to tokens that are available, created by Anthropic and OpenAI and others. And so this industry is different in so many different ways, but the one thing that is very clear, the impact that they're making, the incredible value that they're delivering already is quite tangible. AI natives, all because we reinvented computing.
NVIDIA
Just
は
like
AI
during
ネ
the
イティブな
PC
カンパニー
revolution,
が大
a
好き
whole
だった
bunch of new companies were created. Just as during the internet revolution, a whole bunch of companies were created, and mobile cloud, a whole bunch of companies were created. Each one of them had their own standards, and we're talking about one of the major standards that just happened, incredibly important. And this generation, we also have our own large number of very, very special companies. We reinvented computing. It stands to reason there's going to be a whole new crop of really important companies, consequential companies for the future of the world. The Googles, the Amazons, the Metas, consequential companies that have come as a result of the last computing platform shift. We are now at the beginning of a new platform shift. But what happened in the last couple of years? Well, we've been watching, as you know, we've been working on deep learning and working on AI. The big bang of modern AI, we were right there at the spot, and we've been advancing this field for quite some time. But why the last 2 years? What happened in the last 2 years? Well, three things. ChatGPT, of course, started the generative AI era. It's able to not just understand, perceive and understand, it's able to also translate and generation of unique content. I showed you the fusion of generative AI with computer graphics, and it brought computer graphics to life. You guys, just everybody in the world should be using ChatGPT. I know I use it every single morning, used it plenty this morning. And so ChatGPT was the generative AI era. The second, by the way, generative computing versus the way we used to do computing. It's generative AI is a capability of software, but it has profoundly changed how computing is done. Computing used to be retrieval-based, now it's generative. Keep that thought in mind when I talk about certain things, and you'll realize why it is that everything that we do is going to change how computers are architected, how computers are provided, how computers are going to be built out, and what is the meaning of computing altogether. Generative AI, 2023, end of 22, 2023. The next, reasoning AI, 01. And then took off with 03. Reasoning allowed it to reflect, allows it to think to itself, allows it to plan, break down problems, and decompose a problem it couldn't understand into steps or parts that it could understand. It could ground itself on research. O1 made generative AI trustworthy and grounded on truth. That
確かにね、
caused
リーズニングが入っ
ChatGPT
て
to
性能は格段と
simply
上がりま
took
したよ
off.
ね。
And that was a very, very big moment. The amount of
それこそ
input tokens that was
ChatGPT3 とかはね、全
necessary
然リーズニン
in
グな
order
い
to
からね。
produce
まあ、
and
フォ
the
ーもない
amount
けど。
of output tokens it generated in order to reason, the model was a little bit larger. Of course, you could have much larger models. The model O1 was a little bit larger, not much larger, but its input token usage for context and its output token for thinking increased the amount of computation tremendously. Then came Claude Code, the first agentic model. It was able to read files, code, compile it, test it, evaluate it, go back and iterate on it. Claude Code has revolutionized software engineering, as all of you know. 100% of NVIDIA is using a combination of, or oftentimes all three of them, Claude Code, CUDAx, and Cursor, all over NVIDIA. There's not one software engineer today who is not assisted by one or many AI agents helping them code. Claude Code completely
この
revolutionizes
流れはね、多
the
分
new
オープンクロー
inflection.
の話をする気が
And
してき
for
て、
the first time,
2026年は何かって
you
い
don't
うと、
ask
オープンクローが出
AI
て、うんぬんかんぬんって
what,
話をするんじゃないか。
where,
なんかその辺の話
when,
をね、NVIDIA も
how,
やりそうな、ニュ
you
ークローと
ask
かね
it,
作ってるしね。
create, do, build. You ask it to use tools, take your context, read files. It's able to agentically break down a problem, reason about it, reflect on it. It's able to solve problems and actually perform tasks. An AI that was able to perceive became an AI that could generate. An AI that could generate became an AI that could reason. An AI that could reason now became an AI that can actually do work, very productive work. The amount of computation in the last 2 years, we know that everybody in this room knows the computing demand for NVIDIA GPU is off the charts. Spot pricing is skyrocketing. You couldn't find a GPU if you tried, and yet, in the meantime, we're shipping GPUs out.
需要が増えていますと。コンピュ
Incredible
ーティン
amounts
グ、
of
そ
it.
して
And
NVIDIA。
demand just keeps on going up. There's a reason for that.
まあ
This
1000倍増えたと言われ
fundamental
てもそうかもって
inflection.
気がするよね。正直ね。
Finally, AI is able to do productive work, and therefore, the inflection point of inference has arrived. AI
まあ
now
推
has
論が
to
重要だという
think.
ことを言ってる。
In order to
まあ
think,
推
it has
論
to
が重要だ
inference.
という文脈
AI
で
now
コン
has
ピュー
to
ティング
do.
パワー言ってるから、グ
In
ロ
order
ッ
to
クの
do, it
話を
has
して
to
くれるかもね。
inference.
これは期待
AI
できる。
has to read. In order to do so, it has to inference. It has
LPU
to
の話するん
reason.
じゃ
It
ない
has to
そうそう。
inference. Every part of AI, every time it has to think, it has to reason, it has to do. It has to
い
generate
きなり
tokens.
グロッ
It
クの
has to
話をする
inference.
か、なんか
It's
既存の
way
ポートフォ
past
リオ話
training
から
now.
最後にグロック出
It's
すからね。
in
どっ
the
ちだろう。
in the field of inference. So the inference inflection has arrived. At the time when the amount of tokens, the amount of compute necessary increased by roughly 10,000 times. Now, when I combine these two, the fact that since in the last 2 years, the computing demand of the work has gone up by 10,000 times, and the amount of usage has probably gone up by 100 times. People have heard me say, I believe that computing demand has increased by 1 million times in the last 2 years. It is the feeling that we all have. It is the feeling every startup has. It's the feeling that OpenAI has. It's the feeling that Anthropic has. If they could just get more capacity, they could generate more tokens. Their revenues would go up. More people
もっ
could
ともっ
use
と
it.
需要
The
が増
more
えると、
advanced,
推論の需要が
the
増えるよ。も
smarter
っ
the
と
AI
トーク
could
ン使う
become.
よりもっとジェネレ
We
ーティブ
are
する。
now at that positive flywheel system. We have reached that moment. The inflection, the inference inflection has arrived. Last year, at this time, I said that where I stood at that moment in time, we saw about $500 billion. We saw $500 billion of very high confidence demand and purchase orders
500ビリオンダ
for
ラー。
Blackwell
50兆
and
円。
Rubin through 2026.
お、
I said that last year.
ルビンの話しましたね。
Now, I don't know if you guys feel the same way, but $500 billion is an enormous amount of revenue.
500ダラーの売り上げってなんだでもない。パチパチパチパチパチパチパチ。
I know why you're not impressed, because all of you had record years. Well, I'm here to tell you that right now where I stand, a few short months after GTC DC, 1 year after last GTC, right here where I stand, I see through 2027 at least $1 trillion.
GDDR などを飛ばして GDDR8 を発売します。
Now, does it
2027
make
年には
any
1兆ドルとか言い出したぞ、こいつ、
And
売り上げ
that's
が。
what I'm going to spend the rest of the time talking about. In fact, we are going to be short. I am certain computing demand will be much higher than that. And there's a reason
売
for
り上
that.
げじゃないかな、需要か
So
な。
the first thing is, we did a lot of work in the last year. Of course, as you know, 2025 was NVIDIA's year of inference. We wanted to make sure that not only were we good at training and post-training, that we were incredibly good at every single phase of AI, so that the investments that were made, investments made in our infrastructure, could scale out for as long as they would like to use it. And the useful life of NVIDIA's infrastructure would be long, and therefore the cost would be incredibly low. The longer you could use it, the lower the cost. There's no question in my mind. NVIDIA systems are the lowest cost infrastructure you could get for AI infrastructure in the world. And so the first part was last year was all about
なんだかんだ
AI
で
for
最も
inference.
一番コスパがいい
And
イン
it
フラは
drove this
NVIDIA なんだよって
inflection
言って
point.
ね、高いけど。
Simultaneously, we were very pleased last year that Anthropic has come to NVIDIA, that MSL, Meta SL, has chosen NVIDIA. And meanwhile,
GTC だから、
and
GTC、
as a
データセン
collection, as a group,
ターになる。
this represents 1/3 of the world's
単純に
AI
今は
compute.
5000億ドルの
Open source models
規
have
模で、
reached near the
データ
frontier,
センター
and
に
it is
納入をしてい
literally
て、そ
everywhere.
れが来年
And
は1
NVIDIA,
兆ド
as
ル
you
になる
know,
はずだって言ってるのかな。
today, we're the only platform in the world
あ、
today
1兆じゃない、
that
10
runs
兆。
every
1 兆
single domain of
意
AI
味わかんないな。
across every single one of these AI models in language and biology and computer graphics, computer vision, in speech, proteins and chemicals, robotics and otherwise, edge or cloud, any language. NVIDIA's architecture is fungible for all of that, and we're incredible for all of that. That allows us to be the lowest cost, the highest confidence platform. Because when you're building these systems, as I mentioned, $1 trillion is an enormous amount of infrastructure. You have to have complete confidence that the $1 trillion you're putting down will be utilized, would be performant, would be incredibly cost effective, and have useful life for as long as you could see. That infrastructure investment you could make on NVIDIA, you could make with complete confidence. We have now proven that. It is the only infrastructure in the world that you could go anywhere in the world and build with complete confidence. You want to put it in any of the clouds, we're delighted by that. You want to put it on-prem, we're happy about that. You want to put it in any country, anywhere, we're delighted to support you. We are now a computing platform that runs all of AI.
でもこの勢いは当時のインテルね、往年のインテルを思い起こすよね。
60% of our business is hyperscalers, the top 5 hyperscalers. However, even within that top 5 hyperscalers, some of it is internal AI consumption. The internal AI consumption, really important work, like Rexis is moving from recommender systems of tables and collaborative filtering and content filtering.
ハイ
It's
パース
moving
ケーラー
towards
たち
deep
の中に
learning
も、
and
まあ、
large
いろん
language
な、
models.
AI ワー
Search,
クロードがある。
moving to deep learning, large language models. Almost all of these different hyperscale workloads are now moving, shifting towards a workload that NVIDIA GPUs are incredibly good at. But on top of that, because we work with every AI lab, because we work with every AI, we accelerate AI, every AI model, and because we have a large ecosystem of AI natives that we work with that we can bring to the clouds. That investment, no matter how large, no matter how quick, that compute will be
ハイパース
consumed.
ケーラーは確か
And
に
that represents
60% ぐらい使ってる
60%
の
of
は
our
そうなんです
business. The
ね。
other 40% is just everywhere. Regional clouds, sovereign clouds, enterprise, industrial, robotics, edge, big systems,
まあ、
supercomputing
オン
systems,
プレムで
small
ね、
servers, enterprise
GPU を
servers.
確保するのは相当今大
The
変だから
number
ね
of。systems, incredible. The diversity of AI is also its resilience. The span of reach of AI is its resilience. There is no question this is not a one app technology. This is now fundamental. This is absolutely a new computing platform shift. Well, our job is to continue to advance the technology. And one of the most important things that I mentioned last year was our year of inference. We dedicated everything. We took a giant chance and reinvented while Hopper was at its prime and it was just cooking. We decided that the Hopper architecture, the NVLink by 8, had to be taken to the next level. We completely re-architected the system, disaggregated the computing system altogether, and created NVLink 72. The way that it's built, the way it's manufactured, the way it's programmed completely changed. Grace Blackwell NVLink 72 was a giant bet. And it wasn't easy for anybody. And many of my partners here in the room, I want to thank all of you for the hard work that you guys did. Thank you.
まあ、NVIDIA の各アーキテクチャをこれから一気に変えていくよみたいな感じを言ってたかな。
NVFP4, not just FP4 precision, FP4 is a whole different type of tensor core and computational unit. We've demonstrated now that we can inference NVFP4 without loss of precision, but gigantic boost in performance and energy efficiency. We've also been able to use NVFP4 for training. So NVLink 72, NVFP4, the invention of Dynamo, TensorRT LLM, a whole bunch of new algorithms. We even built a supercomputer to help us optimize kernels and help us optimize our complete stack. We call it DGX Cloud. We invested billions of dollars of supercomputing capability, help us create the kernels, the software that made inference possible. Well, the results all came together, and people used to tell me, but Jensen, inference is so easy. Inference is the ultimate hard. Inference is ultimate hard. It is also ultimate important because it drives your revenues. And so this is the outcome. This is from semi-analysis. This is the largest, most comprehensive sweep of AI inference that has ever been done. And what you see here on the left, on this side, is tokens per watt. Tokens per watt is important because every data center, every single factory, by definition, is power constrained. A 1 gigawatt factory will never become 2. It's physically constrained. The laws of atoms, the laws of physicality. And so that 1 gigawatt of data center, you want to drive the maximum number of tokens, which is the production, the product of that factory. So you want to be on top of that curve as high as you want. The x-axis is the interactivity, the speed of inference, the speed of each inference. The faster you can inference, the faster you could, of course, respond. But very importantly, the faster you can inference, the larger the models, the more context you could process, the more tokens you can think through. This axis is the same as smartness of the AI. And so this is the throughput of the AI. This is the smartness of the AI. Notice, the smarter the AI, the lower your throughput. Makes sense. You're thinking longer. Okay? And so this axis is the speed, and I'm going to come back to this. This is important. This is where I torture all of you. But it's too important. Every CEO in the world, you watch, every CEO in the world will study their business from now on in the way I'm about to describe. Because this is your token factory. This is your AI factory. This is your revenues. There's no question about that going forward. And so this is the throughput. This is the intelligence. Better perf per watt, for a given power of data center, the more throughput, the more tokens you could produce. On this side is cost. Notice, NVIDIA is the highest performance in the world. Nobody would be surprised by that. They would be surprised by the fact that in one generation, whereas Moore's law would have given us, through transistors, 50%, 2 times,
まあ、コストもなんだかんだ
Moore's law
NVIDIA が
would
安いんだ
probably
よという
give
ことを言
us
ってますね。
1.5 times
まあ、
more
H200 と
performance. You
GP300
would have
の
expected from
NVIDIA でこん
Hopper
だけ違うんですよ。
H200 1.5 times higher. Nobody would have expected 35 times higher. I said last
ライバ
year
ルはなんか一
at
定
this
の
time
敷地を超えた
that
ら一気に上がるよっていう
NVIDIA's
数字
Grace
だからね。
Blackwell NVLink 72 was 35 times perf per watt. Nobody believed me. And then semi-analysis came out, and Dylan Patel had a quote. He accused me of sandbagging. He accused me of sandbagging. He says, Jensen sandbagged. It's actually 50 times. And he's not wrong. He's not wrong. And so our cost per token,
50倍すごいね。
our cost per token is the lowest in the world. You can't beat it. I've said
NVIDIA の
before,
ハー
if
ドウ
you
ェア
have
自
the
体は
wrong
高いけ
architecture,
ど、トー
even if it's
クン
free, it's not
あ
cheap
たりで
enough.
見たら一番安いんだ
And
よ
the
と。そん
reason
だけ
for
我々は
that
効
is
率よ
because
く
no
ハー
matter
ド
what happens, you
ソ
still
フトウェア
have to
的にも
build
ハードウェ
a
ア的にも処理できるんだよ
gigawatt
って話
data
ね。
center. You still have to build a gigawatt factory, and that gigawatt factory, for 15 years amortized across,
まあ
that
でもこれ
gigawatt
はその
factory
通
is
り
about
ね、もう
$40
GB300
billion.
NVL7
Even when you
って
put nothing on it, it's $40
ただの
billion
GPU じゃな
in.
くて、
You
もう
better
ラッ
make
ク
for
だから
darn
ね。
sure
まあ
you
今
put
その
the
辺の話
best
してる
computer
け
system
ど、
on
データ
that
セン
thing
ターと
so
かの
that
レ
you
ベル
could
でさえ
have the
特化してる
best
から、だ
token
からエネル
cost.
ギー効率がめち
NVIDIA's
ゃくちゃ
token
高いんですよ。
cost is world class, basically untouchable at the moment. And the
ち
reason
なみに今
that's
ね、
true
最近もう
is
ね、
because
ハー
of
ドウェアの費用じゃな
extreme
くてね、電力
co-design.
で
And
計
so I'm
算す
very
るんだよ、
happy
費用。
that he named us
もう電力が全ての費用の大半だから。なんかチャンピオンだけど、チャンピオンだ。我々がチャンピオンだと。キング NVIDIA。使えてる。
there was a monkey king, token king.
モンキーキングとトーキンキング。モンキー
Well, we take all of our software, as I told you, we vertically integrate, but we horizontally open. We're vertical integration, horizontal open. We integrate all of our software and all of our technology,
垂
however
直
we could
統合
package
し
it
つ
up
つ
and
も、
integrate it into
水
the
平
world's
にね、広げてみますよと言って
inference
ね。まあ、オープンだって言
service
ってね。
providers. And these companies are growing so fast. They're growing so fast. Fireworks, Lynn is here, together. They're just growing so incredibly fast. 100 times in the last year. They are token factories. And the effectiveness, the performance, and the token cost production capability for their factories is everything to them. And this is what happened.
We
We updated their software,
今回は対応して
same
るね。
system, and notice their token speeds, incredible. The difference before NVIDIA updated everything and all of our algorithms and software and all the technology that we bring to bear, about 700 tokens per second average went to nearly 5,000, 7 times higher. And so this is the incredible power of extreme co-design. I mentioned earlier the importance of factories. This is the importance of factory. Your data center, it used to be a data center for files. It's now a factory to generate tokens. Your factory is limited no matter what. Everybody's looking for land, power, and shell. Once you build it, you are power limited. Within that power limited infrastructure, you better make for darn sure that your
単なる
inference,
GPU の
because
話
you know
とかの
inference
レ
is
ベ
your
ルではないよ
workload
ね。
and tokens is your new commodity,
そう、ラックだと
that
か、
compute is your revenues,
まあその
that
電
you want to
源
make
系と
sure
かね、
that the
800ボルト電
architecture
源がどうのっ
is
て
as
話もちょっとした
optimized
け
as
ど。
you can. In the future, every single CSP, every single computer company, every single cloud company, every single AI company, every single company, period, are going to be thinking about their token factory effectiveness. This is your factory in the
トーク
future.
ン AI
And
フ
the
ァクトリ
reason
ーとか
why
ト
I
ー
know
クン
that
ファクト
is
リーの
because
効率
everybody in
性
this
をどん
room
な会社
is
であって
powered
も
by intelligence.
考えないといけない時
And
代
in
が
the
来るよって言
future,
ってる
that
ね。
intelligence will be augmented by tokens. So let me show you how we got here.
On April 6th, 2016, a decade ago, we introduced DGX-1,
GX?
the world's first computer designed for deep learning. 8 Pascal GPUs connected with the first generation
NVIDIA
NVLink,
がなんかそういう
170
スーパーコン
teraflops
ピューター
in
作り
one
始めた
computer,
多
the
分チップ
world's
屋さんから
first computer designed for AI
なん
researchers.
だろうなその次のステージみたいなところに行ってきたのは
With Volta,
やっぱここ
we
が最初
introduced
かな
NVLink switch, 16 GPUs connected with full all-to-all bandwidth,
NVLink
operating
が
as
ね
one
こんな成
giant
長するとは思わなか
GPU.
ったよね
A giant step
昔
forward,
は
but model sizes continued to grow.
なんだジオフォースを2個
The data
つな
center
SLI でつな
needed
げ
to
性能
become
ア
a
ップが入れるため
single
の
unit of
コネク
computing.
ターだと
So
こん
Mellanox
なとんで
joined
もないことにな
NVIDIA.
るとはねこれでかいねメランボックスのインフィニバンド持ってる会社を買収したから
DGX-A100 Superpod
インフィニバン
became
ド
the
自体も
first
そうだし
GPU
NV リン
supercomputer
ク自体の性能
combining
もやっぱそこでどんどんどんどん上がっていったんだよね
NVLink 3 for scale-up, Connect X6, and Quantum InfiniBand for scale-out. Then Hopper, the first GPU with the FP8 transformer engine that launched the generative AI era. NVLink 4, Connect
8
X7,
ぐらいからジェネ
BlueField
レーティブ
3
AI っていうのが騒がれ始め
second
て
generation Quantum
800まで
InfiniBand.
はまだディー
It
プラーニングっていう
revolutionized
文脈
computing.
で普及していったんだよね、まあ、それも十分に重要なことだよね
Blackwell redefined AI supercomputing system architecture with NVLink 72. 72 GPUs connected by NVLink spine. 130 terabytes per second of all-to-all
す
bandwidth.
べてのラックの中の
Compute
GPU
trays
が
integrate
NV リンク
Blackwell
でつながってるとか間違い
GPU,
ない気
Grace
がする
CPUs, Connect X8, and BlueField 3. Scale-out runs over Spectrum 4 Ethernet. With 3 scaling laws in full steam, pre-training, post-training, and inference, and now agentic systems, compute demand continues to grow exponentially.
インフィニバンドとか
And now,
RDNA で
Vera
能力
Rubin.
でつなぐスケールアップ
Architected for every phase of agentic AI, advancing every pillar of computing, including CPU, storage, networking, and security.
これは
Vera Rubin
ベラルビンが
NVLink 72, 3.6 exaflops of compute, 260 terabytes per second of all-to-all NVLink bandwidth. The engine
Groq
supercharging the era
LPU
of
って書いてある
agentic AI, the Vera CPU rack,
マジか
designed for
Groq って普通に
orchestration
書いてある
and agentic workflows. The STX rack, AI native storage built with BlueField
来たよ
4. Scale out with Spectrum X
だ
co-packaged
から正
optics,
式にルビンアーキテクチャ
increasing energy efficiency and resiliency. And an incredible new addition, the Groq 3 LPX rack. Tightly connected to Vera Rubin, Groq's
これは熱い
LPU's massive on-chip SRAM,
こ
a
こは熱
token
い
accelerator to the already
Groq
incredibly fast Vera Rubin. Together, 35 times more throughput per megawatt. The new Vera Rubin platform, 7 chips, 5 rack-scale computers,
そうね昨日
one
の時点では
revolutionary AI
6チップって紹介しましたけどこれが今日から
agentic AI
7チップになりましたね
40 million
Groq
times
入ってる
more compute in just 10 years.
DADAIM
いやーこれは熱いよねだから会場も大盛り上がりでし
どうでしたはてな
ょまだスペックの話はしないけどとりあえず
Now,
出た
in the good old days, when I would say Hopper, I would hold up a chip. That's just adorable. This is Vera Rubin. When we
ベ
think
アル
Ver-
ービン君来たね
when we think Vera Rubin, we think the entire system, vertically integrated, completely with software, extended end to end, optimized as one giant system. The reason why it's designed for agentic systems is very clear because agents, of course, the most important workload is it's thinking the large language model. The large language models are going to get larger and larger and larger. It's going to generate more and more tokens more quickly so it can think more
高級
quickly.
官僚みたい
But
な
it
デザイン
also
で
has
高級
to
感じある
access memory. It's
そうね
going to pound on memory really hard. KV cache, structured data,
なん
CUDF,
かスーパーコンピュ
unstructured
ータ
data,
ー的なデザインとはまた
QVS.
ちょっ
It's
と
going to
違
be
うね
pounding
あれはなん
on
かほら
the,
イキリデザイ
on
ン
the
じゃん
storage system really, really hard,
私は
which
好
is
き
the
なんだ
reason
けどなん
why
か
we
かっこいい絵が
reinvented
ラックに
the
ダーンって
storage
書いてるやつ
system. It is also going to use tools. And unlike humans that are more tolerant
なん
to
かあれじゃない
slower
大
ゼッ
金
トン
み
みたいじゃない
たいなフィン。
AI
Z みたいに
wants
色し
the
てるよね
tools
Z
to be
ウル
as
トラマン
fast as possible. These tools, web browsers, in the future, they could also be virtual PCs in the cloud. Those PCs have to be, and those computers have to be as fast as possible. We created a brand new CPU that's designed for extremely high single-threaded performance, incredibly high data output, incredibly good at data processing,
新しい
and
CPU って言ってるけど、これ
extreme
は
energy efficiency.
ベラだね。
It is the only data center CPU in the world that uses
ベラ
LPDDR5,
ネオバースベースじゃないんだよね、実は。
LPDDR5,
今
and
回からオリンパスベースって
incredible
新しいアーキテクチャ
single-threaded
になって
performance
て、スレッ
and
ドの
performance
ハ
per
イパースレー
watt
ティングになっ
that
て
is
るから、
unrivaled. And so that's
単にシングルスレ
we
ッド性
built
能がいい
that
だけではな
so
いって
that
こ
it
と
could
も
go
言ってるね。
along with the rest of these racks for agentic processing. And so here it is. This is the Grace Blackwell, no, Vera Rubin. Where is it? Here it is. Okay. So this is the Vera Rubin system. Notice since the last time, 100% liquid cooled. All of the cables gone. What used to take
あ、そうそう、今ケーブ
2
ルが
days
ね、ほとんどないんで
to
すよ。
install
NVIDIA
now
の
takes 2 hours.
このシステム。
Incredible. And so the
全部
manufacturing
内部
cycle
で
time is going to dramatically
設置で
reduce.
きるように、ブラックエ
This
ラ
is
ーアーキテクチャの
also
ところがな
a
い。はい、あ、ブラッ
supercomputer
クエっていう
that
か、
is cooled by
グレースホッパーあ
it's
たりから。
cooled by hot water, 45 degrees, which takes the pressure off of the data center, takes all of that cost and all of that energy that's used to cool the data center and makes it available for the system. This is the secret sauce. It is we're the only company in the world that has today built the sixth generation scale-up switching system. This is not Ethernet. This is not InfiniBand. This is NVLink. This is the 6th generation NVLink. This is insanely hard to do well. It is insanely hard to do, period. And I'm just super proud of the team. NVLink, completely
NVLink
liquid
で、
cooled.
インフィニバン
This
とかロ
is
キじ
the
ゃなくて
brand new
NVLink でつないで
Groq
るん
system,
だよっつ
and
っ
I'll
て
show you a
ね。
little bit more about it. This system, 8 Groq chips. This is the LP30. The world's never seen it. Anything that the world's ever seen is V1. This is 3rd generation. And we're in volume production now. And I'll show you more about that in just a second. The world's first CPO Spectrum X switch. This is
CPO っていう
also
ことは
in full
光
production.
かな
Co-packaged optics. Optics comes directly onto this chip, interfaces
光チ
directly to
ップにな
silicon.
って、
Electrons get translated to
それを
photons,
投稿してるよっ
and
て
it
話を
gets
したね。
directly connected to this chip. We
光はね、多分
invented the
今後
process
どんどん
technology
増え
with
てくると思うんだよ
TSMC.
ね。
We're the only one in production with it
やっぱり
today.
もうデ
It's
ー
called
タ
CUDAx.
センターは
It's
電力
completely
の戦いだか
revolutionary.
ら、消費電力を下げるた
NVIDIA
め
is
に
in
ね、
full
光回路っ
production
ていうのは避
with
けられないと
Spectrum
思うんだよね、
X.
もはやここまで来ると。
This is the Vera system, twice the
Vera.
performance per watt of any CPUs in the world today. It is also in production. Well, you know, we never thought we would be selling CPUs standalone. We are selling a lot of CPUs standalone. This is already for sure going to be a multi-billion-dollar business for us. So I'm very, very pleased with our CPU architects. We've designed a revolutionary CPU. And this is the CX9 powered with Vera CPU, the Bluefield 4 STX, our new storage platform. Okay, so these are the racks, and it's
ネ
connected.
ットワークの方か。
Each one of these racks, the NVLink rack, this is, I've shown you guys this before, it's just super heavy. It seems to get heavier every year
そう、何これ電源ケーブルスイッチ
because I think there's just more cables in there every year. And so this is the NVLink rack. We've also
NVLink
taken
rack
this
ついてるから
technology because it is
そ
so
んな構造してんの
efficient to create a data center with these cabling systems, structured cables. So we decided to do that for Ethernet.
これをケーブル
So
と呼ぶか
this is Ethernet 256 liquid-cooled nodes in one rack,
あ
and
の
it is
もう後ろ
also
がスパゲティになる時代では根本的にないんだね。
these incredible
なんかサー
connectors.
バーラックの後ろってね、スパゲティになりがちなんだけど、
You guys
も
want
は
to
や
see
そういう次元ではないんだね。カートリッジみたいな
Rubin
やつ。
Ultra?
ん お、なんか湧き出てきたぞ。なんか湧き出てきたぞ。
So this is the Rubin Ultra compute node. Unlike Rubin that slides in horizontally, Rubin Ultra goes into a whole new rack. It's called Kyber that enables us to connect 144 GPUs in one NVLink domain. And so the Kyber rack, this, I could lift it,
4つの
I'm
ベラ
sure,
と2つ
but I
の
won't.
ルビン
It's quite heavy. This
逆かな
This is one compute node, and it slides into the Kyber rack
4
vertically.
つのルビンと2つのベラ
This
CPU が
is
2個
where it connects into. This is the mid plane. The Kyber racks, those 4 top NVLink connectors slide in and connect into this, and this becomes one of the nodes.
もうコネクター、さっきからずっとこなしてるけど、ケーブルでなんかもう2つをつなげるとかじゃなくて、
This is the mid plane.
物理的にと
And
いう
the
か
back
ガ
of
ツ
the
ガ
mid
ツ
plane,
ケースと
instead
して
of
刺して
this
くるね。
cabling
す
system,
ごいね。
which has its limits in terms of how far we could drive cables, copper cables, we now have this system to connect 144 GPUs. This is the new NVLink. This sits
NVIDIA
also
はもうケーブル
vertically,
じゃないからね。
and it connects into the mid planes on the back.
普通なんか見た目だけでいくとカートリッジみたいになってる。
NVLink switches in the back, one giant computer. Okay?
これは
So
ちょっと面
that
白い
is
ね。
Rubin Ultra. As I mentioned, how about we take this back down? I need the rest of my slides. Oh, it's coming down? Okay. Thank you, Janine. This is what happens when you don't practice.
私は大きいとワクワク。
ね、まあやっぱ大きいことはいいことだからね。
Okay, all right. So, you take your time, just don't get hurt.
なんか疲れてきてるぞ。
You saw
Kawajan疲れてる。
this slide. You know, only at NVIDIA's keynote will you see last year's slide presented again. And the reason for that is I just want to let you know that last year I told you something very, very important. And it's so important, it's worthwhile to tell you again.
去
This
年の
is
発表もう一回
probably
や
the
り
速
直
度
す
比
ね。
較してほしい。
most important chart for the future of AI
気になりま
factories.
すよね。
And every CEO in the world will be tracking it, will be studying it very deeply.
ベン
It's
チマー
much,
クとは
much
言
more
わないけど。
complicated than this. It's multidimensional. But you will be studying the throughput and the
実演で。
token speed of your
実
AI
演で、その場で。
factories. The throughput, token
ま
speed,
あその場で
at
どのぐらい
ISO
ね、トークン
power,
生成速度が変わるのか
because
とか
that's all
出
the
してほ
power
しい
you
けどね、
have.
確かに。
Throughput and token speed for your factories forever. And that analysis is going to lead directly to your revenues. What you do this year will show up precisely next year as your revenues. And this chart is what it's all about. And I said on the vertical axis, thank you guys. On the vertical axis is throughput. On the horizontal axis is token rate. Today, I'm going to show you this. Because we're now able to increase the token speed, and because model sizes are increasing, because the token length, the context length, depending on the different grades of
これなんだ。
different application use case, continues to grow from
モ
maybe
デルのサイズ
100,000
かな？
tokens input length to maybe millions. The
どれぐ
token
らい速くなるか気
input
になる
length
ね
is。growing, and
そう
also
です
the
よね。
output token length is growing. And so all of these
まあ
play
結
into ultimately
構性能が数倍に上がるっていうふうにカタログ
the
スペック上はなって
marketing
ま
and
す
the
けどね。
pricing
どこ
of
までいく
future
か。
tokens.
ただ、
Tokens
最近
are the
の
new
GPU の
commodity,
傾向
and
と
like
し
all
て、
commodities,
ワッパ
once
で
it
計算
reaches
す
an
るから、
inflection, once it
スループ
becomes
ットが高
mature
くな
or
るけど、レイ
becomes
テンシが
maturing,
高くなる
it
と
will
は限
segment
らなかった
into
んだよ
different
ね。
parts.
うん。
The high throughput, low speed could be used for the free tier.
高速化し
The
て
next
一つの
tier
質
could be
問
the
を処理
medium
する
tier.
コストが安くなれ
Larger
ば、
model maybe,
まあ
higher
確かに
speed
ね。
for sure,
その辺がグロックはでも
larger
効いてくる
input
かもしれないですね。
context length. That translates
サ
to a
ブス
different
ク額
price
が
point.
安くなればいいの
You
に。
could see from all the different services, this one is free, it's a free tier.
まあ
The
安くな
first
ると
tier
いう
could be
か多分
$3 per
キャパ
million
シティが増える
tokens.
方
The
が
next
いい
tier
か
could
な。
be
レートリミット
$6
が。
per million tokens. You would like to be able to keep pushing this boundary because the larger the model, smarter. The more input token context length, more relevant. The higher the speed, the more you can think and iterate, smarter AI models. So this is about smarter AI models. And when you have smarter AI models,
AI の出
each
力
one
の
of
サイ
these
ズと秒
clicks
数が伸びて、
allows you to increase the price. So this is $45.
まあ
And maybe one
でも
day
その辺
there'll
も
be
や
a
っぱ確
premium
実に伸びてい
model
ってま
that
すよね。
allows you
AI 動画とか
premium
も、
service that
なんか
allows you to
少なくとも
generate
ジェミニ
token
とかでね、
speeds that
適
are
当に作っても
incredibly
前より
high
全然長い
because
こと
you're
作れ
in a
るからね。
critical
びっ
path
くり
or。maybe you're doing really long research and $150 per million tokens is just not a thing. So let's translate that. Suppose you were to use 50 million tokens per day as a researcher at $150 per million tokens. As it turns out, as a research team, that's not even a thing. So we believe that this is the future. This is where AI wants to go. This is where it is today. It had to start here to establish the value and establish its usefulness and get better and better and better. In the future, you're going to see most services encompass all of that. This is Hopper. Hopper started
何倍の
moved
ブレイ
it,
ク
moved
スルー
the
にな
chart.
るか。
This is 50, this is 100. Hopper
じゃあ
looks like
この
this.
辺が
And you would have
ホ
expected
ッパー
Hopper,
から
the next
変え
generation
て
to be
倍になっ
higher,
てって言って
but nobody would have expected it to be that
何
much
ですか
higher.
これ。
This is Grace Blackwell. What Grace Blackwell did is, at your
35
free
倍って言ってますよ。
tier, increase your throughput tremendously. However, where you mostly monetize your service, it increased your throughput by 35 times. This is no different than any product that every company makes. The higher the tier, the higher the quality, the higher the performance, the lower the volume, the lower the capacity. And so it is no different than any other business in the world. And so now
これは
we're able
多
to
分コス
increase
パで見てるな、この
this tier
35%、
by
35倍はさすがに絶対性能っていうより
and we introduced a whole new tier. This is the benefit of Grace Blackwell, a huge jump over Hopper. Well, this is what we're doing with. Okay, so this is Grace Blackwell. Okay, let me just reset this. And this is Vera Rubin. Okay?
ブラックベルからベラに、ごめん、ルビンになってさらに70、2倍の性能ですって言ってます。マジかよ。
電力コストも出してるのかな。
これ多分電力コスト間違いなく入れてると思いますよ。でもね、これは TPS パーユーザーだから、どんだけのユーザーにどんだけのトランザクションを同時に出せるか。だからスループットを見てますね。これコスパじゃなくて。同時にどのぐらい処理できるかって話をしてる。どのぐらいの低レイテンシーかじゃなくて、どのぐらいの同時アクセスに耐えれるか。
Suppose I took 25% of my power, used it in a free tier, 25% of my power in the medium tier, 25% of my power in the high tier, and 25% of my power in the premium tier. My data center only has a gigawatt.
これが消費電
So I get
力
to
単位で
decide
すね。
how I want to distribute. The free tier
こ
allows
れも
me to
だいぶ
attract
違
more
うね。
customers. This allows me to serve my most valuable customers. And the combination, the product of all that, allows you basically your revenues. The revenues you can generate, assuming this simplistic example, allows Blackwell to generate 5 times
原発減らせ
more
る。
revenues.
まあ、まだまだ全然足りないから減らせないかもしれない。消費電力がどんどん増えているから、消費電力が総量か。まだ減らせないんじゃない？
So Vera Rubin, you should get there as soon as you can. And the reason for that is because your cost of tokens goes down and your throughput goes up. Now, but we want even more. We want even more. And so let me just show you back to this. This is, as I told you, this throughput requires a ton of flops. This latency, this interactivity requires an enormous amount of bandwidth. Computers don't like extreme amount of flops, extreme amount of bandwidth because there's only so much surface area for chips that any systems has. And so optimizing for high throughput and optimizing for low latency
ものすごいたくさんトークンを使うやつがユーザーあたりにどのぐらい出せるかっていうのが結構増えていたから、 理論上はだけど、クラウド 4.6 とか、ああいったところのレートリミットとかが解除されやすい方向に行くはずなんだよね。そこら辺はちょっと嬉しいかな。
At the most valuable tier, we're now going to increase performance by 35x. Now, this very simple chart revealed to you exactly the reason why NVIDIA is so strong in the vast majority of the workloads so far. And the reason for that is because up in this area, throughput matters so much. NVIDIA is so game-changing. It is exactly the right architecture, and it's even hard to beat, even as you add Groq to it. However, if you extended this chart way out here and you said you wanted to have services that delivers not 400 tokens per second, but 1,000 tokens per second, all of a sudden, NVLink 72 runs out of steam and it simply can't get there. We just don't have enough bandwidth. And so this is where Groq comes in, and this is what happens when we push that out. So it goes out beyond. Thank you.
どんどん後ろにシーケンシャルに伸びるよっていうのはルビンの強さと言ってるね。
And if you were to do that, translate that into revenues relative to Blackwell, Vera Rubin is 5x. If most of your workload is high throughput, I would stick with just 100% Vera Rubin. If a lot of your workload wants to be coding and very high valued engineering, token generation, I would add Groq to it. I would add Groq to maybe 25% of my total data center. The rest of my data center is all 100% Vera Rubin. And so that gives you a sense of how you would add Groq to Vera Rubin and extend its performance and extend its value even more. This is what happens. This is a contrast. The reason why Groq was so attractive to me is because their computing system, a deterministic data flow processor, it is statically compiled, it is compiler scheduled, meaning the compiler figures out when the data, when to do the compute, the compute and the data arrives at the same time. All of that is done statically in advance and scheduled completely in software. There's no dynamic scheduling. The architecture is designed with massive amounts of SRAM. It is designed just for inference, this one workload. Now, this one workload, as it turns out, is the workload of AI factories. And as the world continues to increase the amount of high-speed tokens it wants to generate with super smart tokens it wants to generate, the value of this integration is going to get even higher. And so these are two extreme processors you could see. One chip, 500 megabytes. One Vera Rubin chip, 288 gigabytes. It would take a lot of Groq chips to be able to hold the parameter size of Rubin, as well as all of the context that has to go, the KV cache that has to go along with it. So that limited Groq's ability to really reach the mainstream, to really take off, until we had a great idea. What if we disaggregated inference altogether with a piece of software called Dynamo? What if we re-architected the way that inference is done in the pipeline so that we could put the work that makes perfect sense on Vera Rubin and then offload the decode generation,
AI 向けのスケ
the
ジューラーって感じかな。
bandwidth
推論を
limited
いろんなフェーズに
challenge
分解し
part of
て
the workload for
得意な
Groq.
ハードウェア
So
に
we
任せることができるんだ
united,
よね。
unified two processors of extreme differences, one for high throughput, one for low latency. It still doesn't change the fact that we need a lot of memory. And so Groq, we're just going to add a whole bunch of Groq chips, which expands the amount of memory it has. And so if you could just imagine, out of a trillion parameter model, we have to store all of that in Groq chips. However, it sits next to NVIDIA Vera Rubin, where we could hold the massive amounts of KV cache that's necessary in processing all of these agentic AI systems. It's based upon this idea of disaggregated inference. We do the prefill, that's the easy part, but we also tightly integrate the decode. So the attention part of decode is done
コ
on
ントリフェル
NVIDIA's
とレ
Vera
コードの
Rubin,
フェーズで、
which needs a lot of
処
math,
理が違うんだよ
and
ね。で
the
そこでハードウェアを変えちゃう
feed
って、
forward network part of it,
で
the
裏側
decode
で
part is
KV
done,
キャッシュ側で
the
デ
token
ータの
generation
同期を
part
す
is
る。
done on Vera Rubin, on the
で、それを
Groq
スケ
chip.
ジューリング
The
してく
two
れる
of
のが
them
ダイナモ。
working tightly coupled together over today, Ethernet with a special mode to reduce its latency by about half. And so that capability allows us to integrate these two systems. We run Dynamo, this incredible operating system for AI factories on top of it, and you get 35 times increase. 35 times increase, not to mention
35倍
additional
速な
new
のすごい。
tiers of inference performance for token generation the world's never seen. So this is it. This
まあ
is
確かに
Groq.
グロックめっちゃ速いからね。
The Vera Rubin systems,
あ、こ
including
れが
Groq.
Groq
I want to thank
3LPX。さっき
Samsung,
LPX って言ったやつ、これ
who
だね。
manufactures the Groq LP30 chip for us, and they're cranking as hard as they
ブ
can.
ルーフィール
I
ドも入っ
really
てるんだね。
appreciate you guys. We're in production with the Groq chip, and we'll ship it in the second half, probably about Q3
28
timeframe.
GB の SRAM？
Okay. Groq LPX.
メモリーバンド率が40ペタバイトって書いてあるんだけど、テラじゃなくてペタ。
Vera
ちょっ
Rubin.
と単位書き間違ってない
It's
こいつ
kind。of hard. It's kind of hard to imagine any more customers. And the really great thing is Grace Blackwell's early sampling of it was really complicated because of coming together of NVLink 72, but the sampling of Vera Rubin is just going incredibly well. And in fact, Satya, I think, texted out already that the first Vera Rubin rack is already up and running at Microsoft Azure. And so I'm super excited for them. We're just going to keep cranking these things out. We
結
have
構
now
こんなん
set
だ
up
ろう
a
な。
supply
最初の
chain
タイミング
that
か
can
ら
manufacture
統合して出
thousands
してきたね。
a
もうちょっ
week
と、もしかしたら
of
ね、
these
こ
systems,
の
essentially
アクハイアリングしたのって
multi-gigawatts of
去年だか
AI
らグロックが
factories
ね。
per month
少し時間かかるかな
inside
と思った
our
けど、
supply
全
chain.
然すぐ入れてき
And
たね。
so we're going to crank out these Vera Rubin racks while we're cranking out the GB300
LPU そ
racks.
のものは使
We're
わ
in
ないんじゃ
full
ないか説
production.
とかもあったんだ
The
けど、
Vera
普通に使ってきた
CPUs,
ね。
incredibly successful. And the reason for that is because AI needs CPUs for tool use. And Vera CPU was designed
まあ
just
この辺は
perfectly
そう
for
だ
that
ね、
sweet
前回
spot.
話した通り。
Incredible for the next generation of data processing. Vera CPU is ideal. The Vera CPU plus CX9 connected into the Bluefield 4 stack. 100% of the world's storage industry is joining us on this system. And the reason for that is because they see exactly the same thing.
あ
The storage system
あら
is
ゆる
going
ス
to
トレー
get
ジベンダー
pounded.
は俺た
It's
ちと
going
組
to
め
get
って言ってた
pounded
ちょっと
because
よくわかんない。
we used to have humans using the storage systems. We used to have humans using SQL. Now we're going to have AIs using these storage systems. And it's going to store CUDF accelerated storage, QVS accelerated storage, as well as, very importantly, KV caching. Okay, so this is
KV
the
キャッシュ
Vera
が重要だ
Rubin
か
system.
ら、
Now, what's amazing is this. In just 2 years' time, in a 1 gigawatt factory, in just 2 years' time, in 1 gigawatt factory, using the mathematics that I showed you earlier, whereas Moore's law would have given us a couple of steps, we would have, X-factored the number of transistors, we would have X-factored the number of flops, we would have X-factored the amount of bandwidth.
これね、
But with
X86 ホ
this
ッパーからベ
architecture,
ラルビン
we're
にな
going
っ
to
て、
take our token
とんでもな
generation
く性能
speed,
上がって
token
る。
generation rate from
AI フロップスが
2
1.2 ゼタフロッ
million
プスから16ゼタフロップスにな
to
る。
700
ゼタっ
million,
ていう単位がもはやわかんないけど。
350 times increase. This is
そ
the
れでいて
power of
CPU の数、
extreme
じゃあ
co-design.
GPU の数はね、
This is
2
what
分
I
の1
mean
になっ
when
てる
we
しね。
integrate and optimize vertically, but then we open it
トークンパーセ
horizontally
カンド
for
が2
everybody
メ
to
ガトークン
enjoy.
から
This is our
700メガ
roadmap.
トークンに増えてる。
Very quickly, Blackwell is here, the Oberon system. In the case of Rubin, we have the Oberon system. We're always backwards compatible so that if you wanted to not change anything and just keep on moving through with the new architecture, you could do so.
次のアーキテクチャになってくるからね
The。old system, the standard rack system, Oberon, still available. Oberon is copper scale up, and with Oberon, we could also
オベロンっていう
use
のはラックの名
optical
前みたい
scale
な。
out,
ラックアーキテクチャ自体のことをオベロンっていう
scale up to expand to NVLink 576. Okay? And so there's a lot of conversation about, is NVIDIA going to copper scale up or optical scale up? We're going to do both. So we're going to have NVLink 144 with Kyber, and then with Oberon, we're going to NVLink 72 plus optical to get to NVLink 576.
デプロイされますよと。
The next generation of Rubin with Rubin Ultra, we have the Rubin Ultra chip, which is coming, which is taping out, and we have a brand new chip, LP35. LP35 will, for the first time, incorporate NVIDIA's NVFP4 computing structure. Give you another few X factor speed up. Okay, and so this is Oberon, NVLink 72, optical scale up, and it uses Spectrum 6, the world's first co-packaged optical, and all of this is in production. The next generation from here is Feynman. Feynman has a new GPU, of course. It also has a new LPU, LP40, big step up, incredible new technology. Now, uniting the scale of NVIDIA and the Groq team, building together LP40, it's going to be incredible. A brand new CPU called Rosa, short for Rosalind. Bluefield 5, which connects the next CPU with the next Super NIC, CX10. We will have Kyber, which is copper scale up. We will also have Kyber CPO scale up. So for the first time, we will scale up with both copper and co-package optics. Okay? And so a lot of people have been asking, Jensen, is copper going to still be important? The answer is yes. Jensen, are you going to scale up optical? Yes. Are you going to scale out optical? Yes. And so for everybody who is in our ecosystem, we need a lot more capacity. And that's really the key. We need a lot more capacity for copper. We need a lot more capacity for optics. We need a lot more capacity for CPO. And that's the reason why we've been working with all of you to lay the foundation for this level of growth. And so Feynman will have all of that. Let me see if I missed everything. That's it. Every single year, brand new architecture. Very quick.
毎年新しいアーキテクチャ出してきますよと。Every single year, brand new architecture.
Very quickly, NVIDIA went from a chip company to
フェイマンの話
an AI factory company, or AI infrastructure company, AI computing company, these systems.
なんだこれ
And now we're building entire AI factories. There's so much power that is squandered in these AI factories. We want to make sure that these AI factories come together, designed in the best possible way. Most of these components never meet each other. Most of us technology vendors, now we all know each other. But in the past, we never met each other until the data center. That can't happen. We're building super complex systems. And so we have to meet each other virtually somewhere else. And so we created Omniverse, and the Omniverse DSX world, a platform where all of us can meet and design these gigafactories, gigawatt AI factories virtually in system. We have simulation systems for the racks for mechanical, thermal, electrical, networking. Those simulation systems integrated into all of our ecosystem partners of incredible tools companies. We also operated, connected to the grid so that we could interact with each other, send each other information so that we could adjust grid power and data center power accordingly, saving energy. And then inside the data center, using Max-Q so that we could adjust the system dynamically across power and cooling and all of the different technologies we all work on together so that we leave no power squandered, so that we run at the most optimal rate to deliver enormous amount of token throughput. There's no question in my mind there's a factor of 2 in here. And the factor of 2 at the scale we're talking about is gigantic. We call this the NVIDIA DXX platform. And just as all of our platforms, there's the hardware layer, there's the library layer, and there's the ecosystem layer. It's exactly the same way. Let's show it to you.
若干眠気が。
The greatest infrastructure build-out in history is underway.
これは文
The
字通り
world
の
is
AI ファ
racing
ク
to
トリー
build
か
chip, system, and AI factories. And every month of delay costs
あ、いや、あ
billions
くまで
in
デー
lost
タセンターと
revenues.
しては AI ファクトリーだね。
AI factory revenues are equal to tokens per watt. So with power constraints,
こ
every
こまで来る
unused
とあれなんだよ
watt
ね。やっぱ
is
電
revenue
力が
lost.
すごい重要になってくるから、どう効率的
NVIDIA
に
DSX
インフラスト
is
ラ
an
クチャーを組む
omniverse
か、どう
digital
いうふう
twin
に、
blueprint for
電
designing
力
and
系を作るか
operating
みたいな
AI
話だ
factories
ね。
for maximum token throughput, resilience, and energy efficiency. Developers connect through several APIs.
AWS っぽい
DSX Sim
AWS ってわけだから。
for physical, electrical, thermal, and network simulation. DSX Exchange for AI factory operational data. DSX Flex for
このデ
secure,
ータセンタ
dynamic
ーの
power
運用
management
自
between
体
the
をも
grid.
はやそちら化したとし
And
まし
DSX
た。もうこ
Max
いつ
Q to dynamically maximize token throughput. It starts with SIM-ready assets from NVIDIA and equipment manufacturers.
マニファクチ
Managed
ャー
by
はここまで、まあ、
PTC Windchill
ある意味さ
PLM.
それが本業の半分本業みたいなものなん
Then,
でしょうけど、
model-based systems
ここまで
engineering is done in
マニファクチャーを頑張
Dassault
ってるのすごい
Systems 3D experience. Jacobs brings the data into their custom Omniverse app
ね、
to
オンプレミ
finalize
スでデータ
design.
センターを組むときには、こういう世界と戦わないといけないんだよね。
It's
ハイパー
tested with
スケーラ
leading
ーたちと戦うっていうのは。
Using Siemens
なかな
Star
かね、オン
CCM
プレミス
Plus
で
for
ハ
external
イ
thermals.
パースケーラーと同じ効率を出すっていうのはね、現
Cadence
実的
Reality
では
for
ないんだよ
internal.
ね。
ETAP for electrical. And NVIDIA's
効率が
network
悪くても
simulator
絶対コストが安ければっていう話は確かにあるんだけどね。
and virtually commissioned through Procore to ensure accelerated construction time. When the site goes live, the digital twin becomes the operator. AI agents work with DSX Max Q to dynamically orchestrate infrastructure. Phaedra's agent oversees cooling and electrical systems, sending signals to Max Q, which continuously optimizes compute throughput and energy efficiency. Emerald AI agents interpret live grid
結
demand
構ね、
and
まあ
stress
こ
signals
の
and
このレ
adjust
ベルのファシリ
power
ティは別にもちろん
dynamically.
とんでもないけど、そうじゃなくてもね、身近なデータセンター
With
とかでも
DSX, NVIDIA and our ecosystem of partners are racing to build AI infrastructure around the world, ensuring extreme resiliency, efficiency,
ここまで考え
and
てデー
throughput.
タセンターって運用されてるんだって分かったら楽しいから、機会があるとですね、見学とか行くといいと思いますよ。
It's incredible, right? Well, Omniverse was designed to hold the world's digital twin, starting
オ
from
ムニ
the
バース
Earth.
の話しましたけど、
And
ま
it's
あ、オム
going to
ニバ
hold
ース
digital
ってい
twins
う
of
のは
all
NVIDIA
sizes.
の、
And so we have just such a great ecosystem of partners. I want to thank all of you. All of these companies are
まあ、
brand new
AI
to our
も
world.
3D モデ
We
ル
didn't
も
know many of you just a couple years ago.
なんだろう
And
な、
now
デジタル
we're
ツイン
working
も統
so
合するよう
close
な製
together
品では、
to
まさに
work
さっきの
on
工場
and
なん
build
て
together
AI ファ
the
クトリー自体がデ
largest
ジタルツインの
computer
いいデモ
the
になってまし
world's
たよね。
ever seen, and also to do it at planetary scale. So
まあ、デ
NVIDIA
ジタルツイン
DSX
と
is our
VR は似
new
て非なるものかな。
AI factory platform.
でもすごい相関関係あると思ってますけどね。
I'll spend very little time on this time. However, we're going to
NVIDIA
space. We've already been
Space
out in
なんだこれ。
space. Thor is radiation approved, and
宇宙に飛ばすの？
we're in satellites. You do imaging from satellites. In the future, we'll also build data centers
サテライト、宇宙に AI が。
in space. Obviously, very complicated to do so. We're working with our partners on a new computer called Vera Rubin Space One, and it's going to go out to space and start data centers out in space. Now, of course,
すごい
in
ね、デー
space,
タセンターを次
there's
宇宙
no
に作る計画を立て始めたよ、こいつら。
conduction, there's no
まあ確かに
convection,
電力
there's
は
just
太陽電
radiation.
池で賄
And
える
so
からね。
we have to figure out how
それ
to
はなんだ、ス
cool
ケール
these
するの？
systems out in space. But we've
本気
got
で言っ
lots
てん
of
の、こ
great
いつら。
engineers working on it. Let me talk to you about something new.
レイテンシー地獄だろ。
So
まあだからその中で処理してそれを置くんじゃない。オープンクロー来ましたね、オープンクロー。
he wrote a piece of software. It's called OpenClaw. And I
やっ
don't
ぱ今
know
年は
if he
これオー
realized
プンクローの年だよ
how
ね。
successful
去年
it's
が
going to
クラウ
be.
デコードの年だとするならば。
But the importance is profound. OpenClaw is the number one, it's the most popular open source project in the history of humanity, and it did so in just a few weeks.
そうこれすごい。見て、この赤いさっきの謎の線は、あれだよ。人気になったスピードだよ。なんであんな速度で人気になったのかちょっとわかんないけどね。いや、いいソフトだと、てかすごいソフトだと思うけど、しかしみたいな。ネモクローンっていうのはオープンクローンの、まあ、NVIDIA 版みたいな。そんなこと。
You type this into a console, and it goes out, it finds OpenClaw, it downloads it, it builds you an AI agent, and then you could tell it whatever else you need to do. Okay, so let's take a look.
このアニメーションが実際についてくれたらいいけどね。そしたらある意味ナンバーワンなんだから。ブレンダーとかと連携できるのはやっぱりね、まあ、この辺 MCP 使ったりとかもあるだろうしね。
MAC ミニ相当売れたらしいね。
Mac mini ね。私今 Mac 持ってないからさ、あんまりこのオープンクロー界隈の流れに綺麗に追いついてないんだけど、そろそろどっかでキャッチアップしてもいいなと思ってて。オムニバースと統合で、オープンクローが統合できるんだったら、それ相当すごいよね。NVIDIA は結構そういう、まあ、コスモスとかね。なるほど。そういうパイプライン自体をオープンクローで考えてる。
An open source project just dropped. Andre Karpathy has just launched something called
Open Search.
Is a huge deal.
You give an AI agent a task, go to sleep, it runs 100 experiments overnight, keeping what works and killing what doesn't.
I really love
やっぱ自
what
立性が
my
相当
stuff
高いよ。
enables that person to do. And we had like one guy, he told me like he installed it at his 60-year-old dad and like they made beer, connected the machine via Bluetooth to OpenClaw, and then we automated everything, including the whole website for people to order.
Lobsterlager fertig sein.
Hundreds of people are queuing up for lobsters
い
in
や、オ
Shenzhen.
ープンクローは本当に大流行りしたからね。すごいね。オープンクローの人気もすごいけど、オープンクローの人気を見て、この、まあ事実上3ヶ月でキャッチアップしてきたっていうのがなかなか NVIDIA も頑張りましたね。NVIDIA がこの中で持ってきたってことは、例えば Azure とか AWS とか Google のカンファレンスってこれからあるんですけども、
中国政府が使用を推奨し始めたのビビったわ。
そこからそいつらもなんかネイティブオープンクローみたいに出してくるのかな。俺オープンクローみたいな。中国がなんかそんなこと言ってたんですか？それはちょっとびっくり。ドキドキするね。まあ操作しやすくな、まあ中国はマルウェア仕込みやすいから推奨するかも。ちなみにこれ皆さん会社のパソコンとかにおもむろに入れないよね、まだ。
AI に対するスピード感が日本と1000倍違う。
まあいい悪い両方あるとは思うんだけどね。羨ましく思うところはたくさんあるよ。
You could talk to any modality you want. It sends you messages, it texts you, sends you email. So it's got I/O. What
オー
else?
プンクロー系はね、やっぱ渡す権限がすごい強くて、それをレシピというかスキルという形で、オープンな場からね、読み込むって、それを使うっていうフローがあるんだけども、そこの、なんだろうな、脆弱性の管理とかが、まだエコシステムとしてはうまく対応しきれてなくて、結構マルウェア的な振る舞いをするものが潜んでるんだよね。
made it
オー
possible
プンクローに
for us to
個人
create
情報
personal
をどこどこに送れ
computers.
みたいな、
Now
ね。
OpenClaw
そう
has
い
made it
う
possible for us to create
マルウェアとかラン
personal
サム的な動きをするや
agents.
つだから結構いっぱいいるから、
The
そ
implication
この
is
辺が
incredible.
難しいよね。
The implication is incredible. First of all, the adoption says something, all in itself. However, the most important thing is this. Every single company now realize, every single company, every single software company, every single technology company, for the CEOs, the question is, what's your OpenClaw strategy? Just as we need to all have a Linux strategy, we all needed to have an HTTP, HTML strategy, which started the internet. We all needed to have a Kubernetes strategy, which made it possible for mobile cloud to happen. Every company in the world today needs to have an OpenClaw strategy, an agentic system strategy. This is the new computer. Now, this is just the exciting part. This is enterprise IT before OpenClaw. And I mentioned earlier, the way enterprise IT works, and the reason why it's called data centers is because these large rooms, these large buildings held data, held the files of people, the structured data of business. It would pass through software that has tools and systems of records and all kinds of workflow that's codified into it, and that turns into tools that humans would use. Digital workers would use. That is the old IT industry. Software companies creating tools, saving files, and of course, GSI's consultants that help companies figure out how to use these tools and integrate these tools. These tools are incredibly valuable for governance and security and privacy and compliance, and all of that continues to be true. It's just that post-OpenClaw, post-agentic, this is what it's going to look like. This is the extraordinary part. Every single IT company, every single company, every SaaS company will become a gas company. No question about it. Every single SaaS company will become a gas company, an agentic as a service company. And what's amazing is this, OpenClaw gave the industry exactly what it needed at exactly the time. Just as Linux gave the industry exactly what it needed at exactly the time, just as Kubernetes showed up at exactly the right time, just as HTML showed up. It made it possible for the entire industry to grab onto this open source stack and go do something with it. There's just one catch. Agentic systems in the corporate network can have access to sensitive information, it can execute code, and it can communicate externally. Just say that out loud, okay? Think about it. Access sensitive information, execute code, communicate externally. You could, of course, access employee information, access supply chain, access finance information, sensitive information, and send it out, communicate externally. Obviously, this can't possibly be allowed. And so what we did was we worked with Peter. We took some of the world's best security and computing experts, and we worked with Peter to make OpenClaw enterprise secure and enterprise private capable. And we call that, this is our NVIDIA OpenClaw reference for NemoClaw, which is a reference for OpenClaw, and it has all these agentic AI toolkits, and the first part of it is technology we call OpenShell that has now been integrated into OpenClaw. Now it's enterprise ready. This stack with a reference design we call NemoClaw, okay? With a reference stack we call NemoClaw, you could download it, play with it, and you could connect to it the policy engine of all of the SaaS companies in the world. And your policy engines are super important, super valuable. So the policy engines could be connected. NemoClaw or OpenClaw with OpenShell would be able to execute that policy engine. It has a network guardrail. It has a privacy router. And as a result, we could protect and keep the claws from executing inside our company and do it safely. We also added several things to the agentic system. And one of the most important things you want to do with your own custom claws is so that you can have your custom models. And this is NVIDIA's Open Model Initiative. We are now at the frontier of every single domain of AI models. Whether it's Nemotron, Cosmos World Foundation Model, Groq, artificial general robotics, humanoid robotics models, AlphaMyo for autonomous vehicle, BioNemo for digital biology, Earth-2 for AI physics. We are at the frontier on every single one. Take a look.
The world is diverse. No single model can serve every industry. Open Models is one of the largest and most diverse AI ecosystems in the world. Nearly 3 million open models across language, vision, biology, physics, and autonomous systems enable AI builds for specialized domains. NVIDIA is one of the largest contributors to open source AI. We build and release 6 families of open frontier models, plus the training data, recipes, and frameworks to help developers customize and adopt. New leaderboard topping models are launching for every family. At the core, Nemotron, reasoning models for language, visual understanding, RAG, safety, and speech.
Can you hear me now?
Yes.
Hello?
Yes, I can hear you now.
Cosmos, frontier models for physical AI world generation and
シ
understanding.
ミュレーションに対とかデジタルツインに対して、AI で
The
色
world's
付け
first
とかをして
thinking and
合
reasoning
成モデル
autonomous vehicle
合
AI.
成データをちゃんと作ることができるので、
Foundation models
要するに
for
選択
general
ものを
purpose
高めるようにな
robots.
ったロボットだね。こ
BioNemo.
れは
Open models for biology,
コスモスの見
chemistry,
せ方もある
and
んだ。
molecular design. Earth-2. Models for weather and
Earth-2.
climate forecasting, rooted in
地
AI
球2号
physics.
です。つまりカルディアスです。カルディアス。
NVIDIA Open Models give researchers and
カルディアス
developers
はすでにあったん
the
です。
foundation to build and deploy AI for their own specialized domains.
Our models, thank you. Our models are valuable to all of you because number one, it's on the top of the leaderboard. It's world class. But most importantly, it's because we are not going to give up working on it. We're going to keep on working on it every single day. Nemotron 3 is going to be followed by Nemotron 4. Cosmos 1 was followed by Cosmos 2. Groq at Generation 2. Each and one of these, we're going to continue to
モデルを
advance
順調に進
these
化するっていうのは
models.
すごいね。
Vertical integration, horizontal openness, so that we can enable everybody to join the AI revolution. Number one on leaderboard across research and voice and world models and artificial general robotics and self-driving cars and reasoning. And of course, one of the most important one, this is Nemotron 3 in OpenClaw. This is Nemotron 3 in OpenClaw. And look at the top 3. There are the 3 best models in the world. Okay, so we are at the frontier. It is also true that we want to create the foundation model so that all of you can fine-tune it and post-train it into exactly the intelligence you need. This is Nemotron 3 Ultra. It is going to be the best base model the world's ever created. This allows us to help every country build their sovereign AI. And we're working with so many different companies out there. And one of the most exciting things that we're doing today,
この辺がね、もしローカルで動くようになる
is
と
a
ね、
Nemotron
すごいので。
coalition.
性能良かったけど遅すぎて
We are so dedicated
QWEN35
to
でいい
this.
わっ
We
てな
have
った。
invested billions of dollars of
ああ、
AI
なるほどで
infrastructure
すね。
so
や
that
っ
we could
ぱり
develop the
こ
core
のレベルの
engines for
性能を
AI
生か
that's
すには
necessary
もっと
for
もっと
all
速
the
い
libraries of inference
ハー
and
ドウェ
so
ア
on,
が手
but
元にも
also
必
to
要ってことですか
create
ね。
the AI models to activate
メモ
every
リが安く
single
なっ
industry in the
て、
world. Large language models is really
SSD が高
important.
速にな
Of
っ
course it's
て、
important. How could
で、
human
NPU で
intelligence
計算
not
でき
be?
るようになれば、
However,
まあそういう未来も
in
来るかもし
different
れない。
industries around the world, in different countries around the world, you need to have the ability to customize your own models, and the domain of the models is radically different, from biology to physics to self-driving cars to general robotics to, of course, human language. And we have the ability to work with every single region to create their domain-specific, their sovereign AI. Today, we're announcing a coalition to partner with us to make Nemotron 4 even more amazing. And that coalition has some amazing companies in it. Black Forest Labs, imaging company, Cursor, the famous coding company, we use lots of it. LangChain, billion downloads for creating custom agents. Mistral, the Arthur mentioned, I think he's here. Incredible company. Perplexity's computer. Absolutely use it. Everybody use it. It is so good. A multimodal agentic system. Reflection, Sarvam from India, Thinking Machine,
この辺のモデルをどう使いたいのかちょっとまだ見えてないんだよね。完全なオープンウェイトにして、まあ各社勝手に使ってさ、要は自分たちの研究のベースにしたいのか、自分たちの研究の他社の研究のベースにしたいのか、それとも一応普通にこれしたらビジネスにしたいのか、ちょっとよく分かってない。
And they all agree. And they're all partnering with us to integrate NeMo, the NemoClaw reference design, the NVIDIA agentic AI toolkit, and of course, all of our open models. One company after another, there's so many, and we're partnering with all of you. I'm really grateful for that. And this is our moment. This is a reinvention. This is a renaissance of the enterprise IT. From what would be a $2 trillion industry, this is going to become a multi-trillion-dollar industry, offering not just tools for people to use, but agents that are specialized in very special domains that you're expert in, that we could rent. I could totally imagine in the future, every single engineer in our company will need an annual token budget. They're going to make a few $100,000 a year, their base pay. I'm going to give them probably half of that on top of it as tokens so that they could be amplified 10x. Of course we would. It is now one of the recruiting tools in Silicon Valley. How many tokens comes along with my job? And the reason for that is very clear, because every engineer that has access to tokens will be more productive. And those tokens, as you know, will be produced by AI factories that all of you and us, we partner to build, okay? So every single enterprise company in today sit on top of file systems and data centers. Every single software company of the future will be agentic, and they will be token manufacturers. There'll be token users for their engineers, and there'll be token manufacturers for all of their customers. The OpenClaw event This is as big of a deal as HTML. This is as big of a deal as Linux. We have now a world-class open agentic framework that all of us could use to build our OpenClaw strategy. And we've created a reference design we call NemoClaw, that all of you could use, that is optimized, it's performant, it is safe and secure. Speaking of agents, as you know, perceive, reason, and act. Most of the agents in the world today that I've spoken about are digital agents. They act in the digital world. They reason, they write software. It's all digital. But we also have been working on physically embodied agents for a long time. We call them robots. And the AIs that they need are physical AIs. We have some big announcements here. I'm going to just walk through a few of them. 110 robots here. Almost every single company in the world, I can't think of one, that are building robots is working with NVIDIA. We have 3 computers, the training computer, the synthetic data generation and simulation computer, and of course the robotics computer that sits inside the robot itself. We have all the software stacks necessary to do so, the AI models to help you. And all of this is integrated into ecosystems around the world, and all of our partners from Siemens to Cadence, incredible partners everywhere. And today we're announcing a whole bunch of new partners. As you know, we've been working on self-driving cars for a long time. The ChatGPT moment of self-driving cars has arrived. We now know we could successfully autonomously drive cars. And today we are announcing 4 new partners for NVIDIA's robotaxi ready platform.
いやー、そうそう、ロボタクシーね、来るよね。
Hyundai, Nissan,
ホンダの日
Geely,
産。
all together, 18 million cars built each year, joining our partners from
結
before,
構ね、実際今
Mercedes,
年はロボタ
Toyota,
クシーの参入が今ね、
the number
2026
of
年にサービスがやると
robo-taxi
こが
ready
国内も
cars in the
含めて、
future are
ちょい
going
ちょい
to
話
be
題が出てるんで
incredible.
すよね。
And we're announcing also a big
まあ、最初は
partnership
多
with
分ね、
Uber.
特定の地域だけにはなると思いますけ
Multiple
ど。
cities, we're going to be deploying and connecting these robo-taxi ready vehicles into their network. And so a whole bunch of new cars. We have ABB, Universal Robotics, KUKA, so many robotics companies here. And we're working with them to implement our physical AI models integrated into simulation systems so that we could deploy these robots into manufacturing lines all over. We have Caterpillar here. We even have T-Mobile here. And the reason for that is in the future, that radio tower used to be a radio tower, is going to be an NVIDIA aerial AI RAN. And so this is going to be a robotics radio tower, meaning it can reason about the traffic, figures out how to adjust its beamforming so that it could save as much energy as possible and increase the amount of fidelity as possible. There's so many humanoid robots here, but one of my favorites is a Disney robot. You know what? Tell you what, let me just show you some of the videos. Let's look at that first.
The first global rollout of physical AI at scale is here. Autonomous vehicles. And with NVIDIA Alpamayo, vehicles now have reasoning, helping them operate safely and intelligently across scenarios. We ask the car to narrate its actions.
I'm changing lanes to the right to follow my route.
Explain its thinking as it makes decisions.
There's a double parked vehicle in my lane. I'm going around it.
And follow instructions.
Hey, Mercedes. Can you speed up?
Sure, I'll speed up.
This is the age of physical AI and robotics. Around the world, developers are building robots of every kind. But the real world is massively diverse, unpredictable, full of edge cases. Real-world data will never be enough to train for every scenario. We need data generated from AI and simulation. For robots, compute is data. Developers pre-train world foundation models on internet-scale video and human demonstrations and evaluate the model's performance to prepare them for post-training. Using classical and neural simulation, they generate massive amounts of synthetic data and train policies at scale. To accelerate developers, NVIDIA built open-source Isaac Lab for robot training and evaluation and simulation, Newton for extensible and GPU-accelerated differentiable physics simulation, Cosmos World Models for neural simulation, and Groq Open Robotics Foundation models for robot reasoning and action generation. With enough compute, developers everywhere are closing the physical AI data gap. Peritas AI trains their operating room assistant robot in NVIDIA Isaac Lab, multiplying their data with NVIDIA Cosmos World Models. Skilled AI uses Isaac Lab and Cosmos to generate post-training data for their skilled AI brain. They use reinforcement learning to harden the model across thousands of variations. Humanoid uses Isaac Lab to train whole body control and manipulation policies. Hexagon Robotics uses Isaac Lab for training and data generation. Foxconn fine-tunes Groq models in Isaac Lab, as does Noble Machines. Disney Research uses their Camino physics simulator in Newton and Isaac Lab to train policies across their character robots in every universe.
革ジャンと共演しましたよ。2年ぐらい前の GTC かな。だからさっき私のお気に入り聞いたのか。 なんか姿形がどんどん変わっていく。まあでも実際になんか今さ、世界がどんどん変わっていくゲーム的な映像になってるけど、コスモスはまさにこういうことをするためのツールなんだよね。実際の動き、シミュレーションで作った動きと映像的な動きを変えて、なんか視覚から情報を得るAI の学習とか AI の判断があるそこをやる。実際になって
Ladies and gentlemen, Olaf!
ディズニーアゲン2回目の共演ですよ。
Newton works!
Wow!
Omniverse works!
新しいの来たって喜んでるね。
How are you?
I'm so happy now that I'm meeting you.
I know. Because I gave you your computer. Jetson.
What's that?
Well,
君の中にはジェストンが入ってるのかな。なるほど。私はあなたにジェストンを与えた。
And you learn how to walk inside Omniverse.
これ人数 AI はてな。
This is so much better
まあ
than riding a
どっちかな。
And
これが
it was because of
自律
physics
的に AI で運
using
用
this
してるのか、まあ
Newton
裏でね、
solver
ラジコンして
that
るのか
runs
ちょっ
on
と
top
読
of
めない
NVIDIA
ね。
Warp that we jointly developed with Disney and
自律
with
AI でできな
DeepMind
くも
that
な
made
さ
it
そうだし、
possible for you to be
まあ
able
安定性の
to
ためにラ
adapt
ジ
to
コン
the
使ってる
physical
可能性も大い
world.
にあるね。
Check that out. That's how
さす
smart
が
you
にこれ
are.
が単にテープの録音した音声だったら、まああまりにも普通すぎてつまんないから、自律 AI なんじゃないかなと
Could you
逆に
imagine
思いますけ
this?
どね。
The future of Disneyland? All these robots, all these characters wandering around. You know, I have to admit though, I thought you were going to be taller. I've never seen such a short snowman, to be honest.
スノーマン見たことないの？
Hey, tell you what.
大
You want
昔
to
見
help
た
me
から記
out?
憶にない。
Okay. Usually I close the keynote by telling you what I told you. We talked about inference inflection. We talked about the AI factory. We talked about the OpenClaw agent revolution that's happening. And of course, we talked about physical AI and robotics. But tell you what, why don't we get some friends to help us close it out?
Of course.
All right, play it.
NVIDIA の発表っていつも未来すぎて実感がないんだよな。
まあ、私でも逆にだからこれ未来の話をしてるから私結構好きなんですよね。
Hello?
あまり今の話しすぎてもねと思って。何今度
Anybody here?
また偉い新型ロボットくん来たね。こんな自然で動くロボットあったっけ？でもこれは CG っぽいからなんかコンセプチュアルなだけど。どっかがなんかまたアメイジングなロゴ作ったのかと思ったけど。キーノートレセプシリキャップ。昨日収録。なんかあれか。ジェミニとかで最近さ、全部まとめてみたいな流行ってるから、このロボットたちは本物だね。全部最終的に歌にしろって言ったこれはワンチャン生成 AI で全部作ってるかもしれないね、このシーン。最近流行ってますからね。素材を与えてこれを生成 AI でなんだろうな、画像にしてくださいとか、ビジュアルレコーディング、ああいうやつに書いてくださいとか、それの超延長線上で、まあ NVIDIA が
YouTube のショートそんなのばっかだ。
十分。そうですね、Google とかはよく最近そうやってるよね。YouTube ショート、YouTube ショート、なんか YouTube ショートも確かに最近そういうの増えたかも。オープンクロー君がやっぱ今年はでかい。ダイナモの話もさってよくまとまってますよ。
led astray. Safe claws block and say no way. Nemo claws there to guard the course. And yes, my friends, it's open source.
オープンソースかどうかはね、ないけど。
Cars that think and droids that run, this ain't the movies, it's all begun. Alpha Mayo calls the shots, it's a GPT moment for the bots from sim to streets. Now watch them drive, throw your hands up for physical.
この辺、あれ、いくつか実際にあるロボットと、まだあんまり出てなさそうなロボットの両方混じって運動性能とか、ね、このマラカス回しやつは結構有名なやつ、これ、すごい自然な動き。あ、違う違う、自然な動きじゃなくて、俺は実際アメリカで売ってる方です。意外とまとめ長い。なんかもうちょっと30秒ぐらいの動画かと思ったけど、長い。まあ、ロボットの話をしやめたからそろそろ終了か。おー、カニがオープンクロー相当今年だとオープンクローンとしだしてなるだろうと NVIDIA 考えてるのね、革ジャンは。だから最初はもうこれを全力アピールしてんだね。じゃあねー。じゃあねー、なんかディスニーくん。喋ってるけど聞こえない。音声乗ってないよ。あ、みんな帰り始めた。混むからな。これどこ？コンベンションセンター？そういえば。サンフランシスコ、コンベンション、でもどこだこれ。コンベンションセンターっぽいような、そうでもないような。まあ、こう終わりですかね。いやー、皆様、お疲れ様でございます。はい、これ
来
にて終了ですけど。
年は人間がいらないで科学研究をする AI 学者の話していると思うわ。
なんかそういう話もちょいちょい出てきましたもんね。どっちかというと、それは、でも、Google が得意そうだよね。NVIDIA もやるかもしれないけど、結構 Google の方がそういうの好きそうなイメージがある。いや、どうですかね、今年の GTC は。まあ、軽く振り返ってみるとですが、そうね。やっぱり個人的にはですけど、眠い。まあ、それは、ね、心の声を置いとくとして、やっぱ LPU が、結構、しっかりとポートフォリオの中に入ってきたのは、まあ、驚きというほどではないんだけど、このフェーズでしっかり固めてきたなーっていうのは感じましたね。LP の話間違いなく今回すると思ったんだけども、単純に、買収というか、悪ハイアリングしました。これから頑張っていきます。みたいな感じで、実際の製品になるのは来年以降かなっていうふうにも正直と思ってたんですよね。ルビンでは間に合わなくて、もしかしたら、フェイマンからかなみたいな、そういうふうにも思ってたんですけども、で、きっちり、間に合わせてきましたし、風の噂だとね、いや、実は LPU のハードウェアをそのまま、そのポートフォリオに入れるんじゃなくて、基本的には、今後のCUDAタイルとかを進化させる中に彼らのテクノロジーを、入れていくんじゃないかみたいな話もあったんですけども、まあそれはそれでやるかもしれないが、LP は LP で普通に入れるよみたいな話を、今回実際のね、発表の中で聞いて結構イメージがつきましたかね。うん。あとすごいね、トークンっていう言葉を繰り返したよね。トークンジェネレートって話の中で、めちゃめちゃ言ってたから、やっぱトークンと電力の関係性というのが、今後のね、いろんなものを表現するようになるのかなと思いますね。例えば、今日いくつか AI のモデルの話ってあったと思いますけど、あんまり、いわゆる AI ベンチマークで賢さがどうみたいな話って多分なかったと思うんですよね。それよりも、 まあもちろん、NVIDIA の発表だからっていうのはあるんだけども、どのぐらいの効率、あるいはどのぐらいの絶対性能で、結論というかね、答えが出せるのかみたいな。答え違う。ハードウェア的なね、費用感が出せるのかとか。そういうところがね、全体的に強調されていて、で、いろんな会社が、どんどん、そのトークンジェネレーション、つまり AI から逃げられないよと。で、そのトークンをたくさん作るためには、一番効率がいいのは NVIDIA だよね、みたいな、そういうストーリーの話になってたような感じがしますね。あとは、結構ソフトウェアスタックの話も今回はね、結構中心的に語ったのかなと思っています。まず一番ね、初っ端から、単純にこのCUDAがいいとか悪いとか話はもうしてないんだよね、彼らは。で、CUDAをさらにその派生みたいなものとして、非ストラクチャーデータの、CUBEC と、ストラクチャーデータ向けの CU データフレーム、CUDF。この2つが、すごく重要なんだと。で、それだけじゃなくて、車だとかもそうですし、いろんな各産業に対して、ドメインスペシフィックなアルゴリズムをきちんと提供していく。それ我々は、そういったことをまず垂直統合で、ハードウェアからソフトウェアのアルゴリズムまで全部やると。そして、オープンにいろんなエコシステムっていうか、いろんな産業につなげていく。この2つがね、結構キーワードとして前半語っていたかなと思います。で、ちょっとね、完全には聞き取れてなかった部分もあるんだけども、HPC に関してもね、このテンソーフローと HPC の部分でね、ごめん、テンソーフローじゃないや、テンソーコアと、HPC の部分でね、結構話題を引っ張っていたんですけども、あれが何かというとですね、やっぱ HP 性能がどんどん下がっているんですよね。もうちょっと言うと64ビットの回路を、割り食ってるんですよ。最近の新しいアーキテクチャって。なぜなら AI アクセレーターとしてはその辺がいらないから。ただ、スーパーコンピュータの計算にやっぱその辺重要なのですが、それを4ビットのテンソルコアをうまく組み合わせることで、最終的には目的の性能が出るっていうことが、そこら辺のことをね、言ってたわけですね。はい、ちょっと眠くなって頭が尻滅裂になってきたな。一回、仕事前に仮眠を取ろうかな。悩ましいね。またハードウェアの話が、その後来たって感じかな。全体的に個人的にはね、結構面白い。で、最後にね、ロボットとかね、自動運転の話をして、全体的にね、結構個人的には満足な、GTC だったかなと思います。この辺のネタは、来週はね、ちょっとお休みを今週末って言った方がいいかな。今週末はね、配信お休みしようかなと思ってるので、翌々週ぐらいにね、ちょっともう少し整理した段階で、喋れたらいいのかなと思います。今回はね、一旦このキーノートみんなで一緒に見たということでいいでしょう。はい、というわけでね、もう5時41分ということでね、そろそろ本来だったらね、起き始める。いや、まだまだ夢の世界で本来はいろんな方がいらっしゃると思いますけど、私はね、仕事に行くために仮眠を取るかどうかを悩まないといけないので、よろしくお願いします。はい、というわけでどうもご視聴ありがとうございました。バイバーイ。またねー。
OTS